I'm audible.
Yes,
Hello,
good
Jyoti.
afternoon, sir. Yes, good afternoon, sir.
Okay, now start your presentation and open your video.
Okay, I can share my PPT, sir.
Hello.
Uh, can I share my PPT, sir?
Okay. Share your PPT.
Okay, okay.
नहीं ऑडियो HDMI के थ्रू यानी स्पीकर्स के थ्रू.
Is it visible to you, sir?
Yes, it is visible now. Present yourself in a presentation mode.
Okay, sir. Good afternoon, sir. My name is Jyoti Kataria. I am a research scholar at StarX University, Gurugram. I am presenting here intrusion detection framework for IoT environment. An intrusion detection system is a security tool that monitor network traffic or system activities like malicious activities, abnormal behavior, or policy violations. And
Jyoti, can you please present in presentation mode? Switch your presentation mode.
wait, sir. Present.
Okay, continue.
Okay. The presentation is visible to you, sir. Actually, it is not visible to me.
Jyoti, please continue in full screen.
Okay. Okay, sir. My presentation is visible to you, sir.
Yes, visible.
Okay. Okay, here is the problem statement. Sir, my topic is Intelligent Intrusion Detection Framework for Multi-Cloud IoT Environment, and it is by using Swan-based deep learning classifiers, sir. I am a research scholar for StarX University, sir. And here is the
Yeah, I will change your topic. Actually, you have submitted another topic to present here. I have list about your topic, presentation topic. It is slightly different.
no, sir. I have submitted this topic, sir.
You have submitted the topic enhanced intrusion detection system for black hole attack.
Oh, actually, sir, I have changed the name, sir. Actually, topic is on. This is only.
Okay, then continue. Okay.
Okay, yeah, sir. IoT is basically rapidly transformed into various sectors with the 4.1 billion connected devices projected by 2025. The widespread.
ज्योति
हाँ जी सर.
ज्योति आप पहले कंफर्म करो ये फर्स्ट जो टॉपिक जो आपकी जो टॉपिक है वो फर्स्ट स्लाइड पे लेके आओ क्योंकि हमें नोट करना पड़ेगा क्योंकि आपने अदर
Actually,
अनदर
so
टॉपिक हाँ फर्स्ट टॉपिक फर्स्ट स्लाइड
okay.
वेट
Wait, sir,
हाँ
wait.
फर्स्ट स्लाइड पे आप लाओ और थोड़ा वेट करो क्योंकि आपका टॉपिक चेंज है तो हमें नोट करना पड़ेगा
Okay, wait. Sir.
Jyoti, share your slide.
Yes, I'm sharing, sir. Is it okay, sir?
Yes. Wait for wait करिए आप.
Okay, sir, I'm waiting.
Okay, continue.
Okay, sir. Sir, IoT has rapidly transformed various sectors with over 4.1 billion connected devices that is projected by 2025. The widespread adoption exposes IoT ecosystems to significantly security tasks, including network-based attacks like DOS or botnets, etc. And I'm using here an intrusion detection system for monitoring different type of networks that there are malicious activities are identifying. So this study represents an intelligence IDS framework so that we can remove that type of errors or challenges that occur in the IoT environment in multi-cloud system. So here is the problem statement, sir. Traditional IDS struggle from volume, variety, and velocity of IoT data. So there is a difficulty in detection of real-time systems, or here are high false positives are there also, and there is a need for scalability, adaptive, and intelligent IDS systems. My research objective is to design intelligent IDS that is using multi-cloud by IoT and reduce the false positive and improve the accuracy rate. And I also integrate the deep learning and SWOT intelligence system in that. And I also want that real-time monitoring will be there, and there is the adaptive response also. There are many type of literature reviews I have used in there, and here I'm starting the main course of the PPT. First, about IDS. IDS is a vital tool for monitoring and analyzing data to detect the unauthorized access or anomalies, any type of anomalous behaviors. Or there are the many type of core functions of IDS are there, means confidentiality, availability, and integrity also. And there are the types of IDS, means I'm classified these in three types. First one is signature based, second one is anomaly based, third one is hybrid. Signature based IDS are that are highly accurate for known for attacks, or it cannot connect new or unknown attacks, or require frequent updates. That is signature based IDS. And anomaly based IDS, these are the potential intrusions for flagging deviations or learned baseline of normal behavior. The key characteristics of the anomaly based is IDS are can detect new and unknown attacks that is not in signature based, and a higher rate of false positives and adapting of evolving threats. And hybrid is the combination of both of these, that is signature based and anomaly based, that is provide the comprehension protection for the IDS security. And common type of attacks are there are user to root, probing, denial of service, remote to local. In the user to root attack, an attacker gains initial user access so that it can exploit the vulnerabilities of the root, so that gaining full system controlling. And second one is probing, that a method in which attacker gather information about the weakness of the system so that he can cause immediately harm to the system. This is often for mainly it is used for damaging attacks. Third one is denial of service. These attacks are to prevent authorized users from accessing a system or network so that resources or different type of requests are there. And the third one is remote to local, in which a hacker sends data packets from a distance to target a system or to gain the unauthorized access of the sensitive data and posing them a legitimate user. So here is the proposed framework study in which we study the IDS framework for leveraging machine learning and deep learning to address different security challenges in multi-cloud or IoT environment. So these key components are cloud computing, deep learning, swarm intelligence, etc. So here is the methodology or experimental setup. Objective in which I have used the random forest algorithm for detecting different type of network intrusions, and the dataset was used as NSL KDD dataset for a particular benchmark for intrusion detection. There are 41 features, like there are a protocol type or many type of services are there, and two primary classes. First one is non-malicious, that is normal, and the second one is malicious, that is for attack. And the methodology that I have used here, first one is I have to collect the data and pre-process the data by categorical featuring or convert it to numerical values. Second, train and test the data. And after that, model training is used. And last one is evaluation, that is using accuracy or confusion metrics, etc. There is the Python code snippet that is used. Scikit library I have used, and pandas for data manipulation, and NumPy for numerical type of operations. And here are the experimental results by using the random forest model performance. And the high F1 score 98.4 that indicate the excellent balance between precision and recall, and effective intrusion detection with minimal false positive, because here is the issue of false positive that are more in the other detection system. So here I reduce that. And the key observation here is that the model demonstrate high effectiveness at correctly identifying both malicious and non-malicious network traffic with exceptional balance between precision and recall. And here is the classification report at the normal class, at attack class, with accuracy of average and weighted average. And here is the confusion matrix analysis for true positive, true negative and false negative. The key findings of this PPT is that high accuracy, the data set I have used from NSL KDD, that demonstrating the exceptional performance in normal and malicious and non-malicious traffic. And balanced performance is the random forest classifier I have used for a balance capacity to detect both the malicious and non-malicious traffic with the high precision and recall for both the classes. And lower error rates, the low numbers of false positives and false negatives confirm the model's reliability that in the real world scenario while minimizing the false alarms in the crucial. And superiority that random forest model performance surpasses that the conventional classifiers like SVM and KNN. We can use also ensemble learning to approach and combine multiple type of decision trees. Here is the conclusion, sir. Accuracy rate is 99% achieved by using this intrusion detection system. And suggestions or future work is that hyperparameter tuning, we can use it in a grid search or random search for fine tuning of parameters using these methods. And advanced feature engineering we can use also here, that improve the model performance and reduce the computational complexity. We can also use it in deep learning applications like CNN and RNN to enhancing the detection capabilities for particularly large and complex data sets. We can also integrate it with the real world integrations, optimizing the model for faster processing and implement it in real-time intrusion detection systems such as multi-cloud environment or especially in IoT. And adversarial attack assessment evaluate the model's resilience against adversarial attacks like malicious actors that trying to evade the detection the systems. Thank you, sir.
Jyoti, am I audible?
Yeah, yes, sir, you are
Yes,
audible.
sir. There is a question for you.
Ji,
You
sir.
have reinforced algorithm.
Yes, sir.
Have you gone through any other algorithm for the same purpose?
Yes, sir.
What are those?
Sir, can you please repeat the question, sir?
I just want to know about some other algorithms other than what you have used for this work.
Okay,
Have you
no,
gone through some other algorithms, very fascinating and good algorithms, which are
uh,
very much used for this purpose?
no, sir, I have not gone through any other algorithm still.
So you are getting 99% result for,
Ye-
by using this algorithm.
Yes,
So
sir.
you should go to any other some more useful algorithm so you can get more accurate result.
Actually,
And
I'm
secondly,
working on it, sir,
yeah,
but still not find as accuracy as that.
so 99% is very technical, but I know some other
Sir,
this
actually,
algorithm.
other classifiers like SVM and KNN can be also used, but these are the traditional classifiers for using performance matrices. So, superiorly, I am trying to using the ensemble
So,
learning approach so that I can maximize the performance.
but just I want to know, you have mentioned that Swarm Intelligence your model.
Yes, sir.
You have mentioned Swarm Intelligence in your model.
Yeah, yeah, yes, sir. I have mentioned.
What is that? How and how you have used it?
Mm.
Okay, thank you. Any other question? Okay, thank you. Now you can shut down your presentation. Next. Who is next? Please mention your full name. Who is appearing in this presentation as HP? Participants. कोई नहीं है ये तो कहते गणेश को यहाँ पे भैया अपने वो करते हैं चल इसको भेजो तो सीरियस है तेरा पहले क्या रहा है हम तो 4 मिनट का 3 बजे तक ठीक है ये 1:30 बजे हो रहा है ये भी नहीं What is your full name? Sir, we are
सर मेरा प्रेजेंटेशन होगा पेपर का तो
कितने
3:30
बजे आप
बजे मैं ज्वाइन करने का अभी मैंने ट्राई किया कि हो कि नहीं है मैंने टेस्ट कर रहा हूँ मतलब
सर
3:30 बजे सर
what time you have given for the presentation?
3:40
3:40.
सॉरी सर you weren't audible.
You want to present your presentation now?
No sir, I think I will be presenting at 3:30.
Okay. You are
Can I
going to
present,
present
can
3:40.
I present now?
Already. Are you ready with your first
So are you saying something to me?
Are you going to present?
So my time is for 3:40. So
If you're comfortable, you can start now.
okay, so sir, give me 5 minutes.
Okay.
Hello, sir. Sir, sir, am I audible? Sir,
Yes, you are audible. Are you ready with your presentation?
when to start the presentation, sir?
Yes, you can start your presentation. Share slide.
Sir, your voice is not clear, sir.
You can start your presentation.
Sir? Sir, once again.
Sir, I can start.
So if you others, wait for let's start. First, legalization.
Sir, your voice is not clear, sir. Can I start, sir?
Yes, yes, start. Yes.
Sir, is it viewing, sir?
Yes, yes. Start.
Okay, sir. Okay, sir. Good afternoon, one and all present here. Myself, G. Bhuvanya, PhD Research Scholar in full-time, PG in Research Department of Computer Science, Chikana Government Arts College, Tirupur. Under the guidance of Dr. M. Gobi, sir, Associate Professor, PG and Research Department of Computer Science, Chikana Government Arts College, Tirupur, Tamil Nadu, India. Today I am going to present a secured hybrid tool for crop yield prediction using machine learning algorithm. In nowadays, agriculture plays a vital role in for farmers. To produce a prediction, machine learning algorithms are skilled on vast volumes of information. As a significant global industry, agriculture depends on farmers producing sustainable and profitable crops. Crop production can be significantly impacted by poor crop selection, so that we have developed a machine learning algorithm for a prediction of crop for better yielding. These are the contents we are going to see. In abstract, crop prediction is essential for sustainable agriculture, and machine learning technique shows a great assure in this area. A hybrid classification algorithm approach has been used for classification process. By using this classification, the crop has been predicted successfully for better yielding. Before the classification process, the feature selection has been done through a hybrid feature selection method. Using that feature selection, overall the features, some of the features, important features only have been selected. After that, the crops has been categorized using a hybrid classification algorithm. This hybrid classification algorithm model has performs well, and it proves the efficiency of the model. And this hybrid classification algorithm representation is concurrent to our expected information and significant implication for farmers, agricultural stakeholders, and policymakers. In introduction, forecasting the weather and estimating the amount of rain that will fall in a region may be quite time consuming. The factors such as the nitrogen, phosphorus, potassium, and temperature, humidity, and pH are taken into an account and these factors that have a great impact on amount of effective rainfall. These factors are taken into an account and processed in a machine learning algorithm called hybrid classification algorithm. After that, the feature selection and classification has been done. At last, the crop has been predicted. These are some of the literature surveys. In first, Mariamal et al. Presented a novel feature selection technique known as modified recursive feature elimination technique, and Yogesh Gang et al., who combined agronomic principles of crop modeling with the machine learning to design a machine learning based baseline for a large scale crop yield prediction, and so on. First, the problem definitions are crop yield prediction is one of the challenging problems in precision agriculture, and so many models has been proposed and validated so far. The manual crop prediction is error prone and time consuming. So that we have presented a new machine learning technique for crop feature selection and classification based on their classes. These are the methodologies which we have been developed. In first one, the data collection and pre-processing has been done. After the data collection and pre-processing, the second step called a hybrid feature selection algorithm has been introduced and the features has been selected. After the selection of features, the hybrid classification algorithm has been newly proposed and classes has been labeled. We have seen fully. In first step, the data collection and pre-processing. For data collecting, Kaggle repository, we call Kaggle repository, we have collected in that data, which is called the method of gathering and evaluating data from lot of sources called Kaggle repository. It is necessary to pre-process the data prior training the model. Data cleaning is also the process of data pre-processing. The redundant attributes has been removed and it's not taken into an account when predicting the crops. To improve the accuracy, the hybrid feature selection must remove undesirable attributes and missing values must be removed or filled with the not a number value. After the data pre-processing, the features has been selected using our newly proposed hybrid feature selection algorithm. This newly proposed hybrid feature selection algorithm has been evolved from the foundation of recursive feature elimination, which is RFE method, and forward feature selection and support vector coefficient, which is served as a foundation for our hybrid feature selection strategy. By combining all this, we have developed an algorithm called hybrid feature selection. At last, using the probability value, we have selected our features. By suggesting HFS recursively eliminate the character at each stage and reclassifies the enduring features by regressing support vector coefficient on equilibrium attribute. Only weak attributes will be eliminated using hybrid feature selection algorithm. These are the selected features which output shown, and that output features correlation matrix has been shown. For classification, we have developed our hybrid classification algorithm with the help of a random forest and support vector machine. Each algorithm has its own strengths. We have developed an algorithm called a random forest and support vector machine. By combining these two, we have developed an algorithm called hybrid classification algorithm. By using this, all the 22 classes, it has predicted one good crop for better yielding. By using Python 3.8 simulation version, experimental evaluation is found that recommended hybrid algorithm perform fine when run on 3.21 GHz in x64 based on Intel i5 series PC with 8 GB memory and Windows 10 OS. After the classification process, we have evaluated our model because we have to know that our model is good. So that we have evaluated our model using performance measures called R-square, MAE, precision, recall, FN score. In R-square, which is nothing but coefficient of determination, which measures the proportion of variance explained by the model. In MAE is a mean absolute error, which is an average absolute difference between predicted and actual values. It's a precision. Precision is a proportion of true positives among all positive predictions. And recall. Recall is a proportion of true positives among all actual positive instances. And FN score is a harmonic mean of precision and recall. Accuracy is the proportion of correctly classified instances. These are the comparison results for hybrid algorithm. First one, random forest results, and the second, support vector machine results, and the third one is showing our proposed hybrid algorithm results, accuracy, precision, recall, and reference score. It achieves 89.97% accuracy. The confusion matrix of splitting a training set is 70% and testing set as 30% is a best accuracy for our model. At last, a conclusion. First, the review and analysis of crop prediction has been done. First, the data set has been collected from a Kaggle repository, which is crop recommendation data set. In that, it having a factor such as nitrogen, phosphorus, potassium, temperature, humidity, rainfall, and 22 labeled classes. After collecting the data set has been pre-processed and rectified with the missing values. After that, the feature selection has been done through a hybrid feature selection algorithm called with the help of feature elimination and support coefficient. After that, the feature selection process, the classification has been done called a hybrid classification algorithm. By using that hybrid classification algorithm, among the 22 class labels, a crop has been predicted for a better yielding. After the classification process, the performance measures has been evaluated for validating our model. The performance measures which are used are R square, MAE, precision, recall, FN score, and accuracy has been used. These are the references, some of the references. Thank you. Sir?
Okay. Okay. Madam,
Sir?
what are the methods you have used for data cleaning?
Sir? For data cleaning?
Data processing phase.
So for data cleaning, we have used probability method, sir.
Okay. Is there any other method for doing the same thing?
So probability method and first order logical decision method, sir. By combining that, we have rectified the data pre-processing, sir.
Have you checked your model performance on the real-time data?
Sir?
Have you checked your model with real data for predicting the
Yes,
crop?
sir. Yes, sir. We have checked the model, sir.
Okay. Thank you.
Thank you so much, sir.
Who is next? Gautam S. Okay, Gautam S. Gautam S. Chalo.
Yes, sir. Can you hear me?
Gautam S, are you ready for presentation?
Sir, am I audible?
Yes, yes, you are audible. And are you ready with your presentation?
Let me share my screen, sir.
Okay, start your presentation. You're sharing screen with the presentation.
Sir, can you hear me?
Yes, yes, you are audible and you can start the session.
So, is my screen open? Sir, can you hear me?
And you can continue now.
Yeah. So, good afternoon, sir. Thanks for the opportunity. So, as you can see my screen, so this is Gautam, research scholar, and in the Don Bosco College, Yelagiri. Actually, it is located in Tamil Nadu. So, my presentation today is about the boosting approaches which we use for the prediction of the structured data. So it is like a comparison. I mean, I would say it is a review paper between XGBoost and LightGBM. It is a review paper actually. So let me proceed further. So I am just using the data set and the process which I follow only for the cardiovascular disease prediction. So in the global world, you can see almost 80 million deaths annually due to COVID. I mean, the cardio disease. This is the statistics from World Health Organization. So cardiovascular disease are the leading cause of the death worldwide. So as you can see, there are more limitations to find out or to predict the cardio diseases. So the traditional methods, what we follow will take time actually. So to predict the disease, whether the person requires immediate medicine or anything, it takes time. So my plan is to introduce an AI model, so which can predict the disease quickly, but it is not a final solution. It will be a like of a kind of helping source for the doctors to predict the issue or treat the patient. However, so there are many studies or papers published already, but there are some gaps in those things. So I found out the gaps. So existing studies talks about XGBoost or LightGBM. So separately, not combining together. If it is combined, then there is no head-to-head comparison. So how these boosting frameworks works. So my paper actually talks about head-to-head comparison, and I have introduced this explainability by having SHAP, SHAP. So it is a explainable framework which explains the prediction of the AI, not from the data or not from the user's input, anything. So we need to make the output from the AI to be consistent in order to predict the outputs. So these are all the contributions that I am planning to produce. So what is XGBoost or what is LightGBM? So these both are actually a boosting frameworks. So recently the boosting frameworks are becoming state of the art in predictive actually. So mainly I focused on XGBoost and LightGBM, so which predicts the structured data, not the unstructured data. So which predicts the structured data more in an appropriate way. Okay. And also, if there are any imbalanced things in the data set or in the class, our boosting approaches helps us to make it balanced. So it can process mixed data. So either it could be numerical data or it could be a character data, whatever it is used to process the mixed data types. And also the output that we get from these boosting frameworks. No? So it is quite robust comparing to other models that I would say. So how do these boosting works? So when we talk about XGBoost, no? So it talks about accuracy and regularization. So it is actually good for the structured data, and if we use some unstructured data, the XGBoost result may vary. So it may not be consistent. When we talk about light GBM, so it works between structured data as well as unstructured data. So this focus mainly on the speed and efficiency. So as you can see in the table, I've segregated, I have shown you the difference between these two frameworks. So when we say XGBoost, it works level wise, like it predicts the best possible way, not everything. When we say light GBM, it predicts like a binary tree. So it reaches to the end of the tree and fetches the information. If it is not consistent, then comes back to another leaf. So likewise, it fetches the data. That's why we are saying that it is a speed and efficient. So in memory usage also, you can see light GBM is taking lower memory and XGBoost is taking more memory. And the data set which I'm talking now, so best for small medium data set, that is XGBoost. When we have large data set, light GBM is the best to predict those informations. So these days we are not handling the data, minimal data, right? So huge number of data is being processed. So in this paper, as a conclusion, I will say that light GBM is the best to predict structured data than XGBoost. So for this paper, no, so I've prepared a Python script which process the data and produce the output. Included the images in the upcoming slides. So I have taken the data from online. It is from the Kaggle site, so which has 10,000 samples. It is structured data only, and I've pre-processed with the same what to say, the platform, I can say. So whatever the parameters, whatever the place, whatever the model that we use, no, so for XGBoost and light GBM, both are same. So model training, you can see both algorithms trained under identical experimental conditions. So to find out which is better, we need to keep it in the identical condition, so that we can get the difference between those. Finally, I've added this explainability analysis, which analyze the prediction from the AI, not from the users, as I said earlier. So clinical implementations, I would say anomaly detections, which means, so this old peak in the sense to predict cardiovascular disease, we have certain tests, right? So like ECG or stress depression analysis, like this we have. So this old peak speaks about the stress detection. So because of the stress also, a person can have this heart diseases. So to predict those things, it works well. And interpretability so provides both global and local explanations, ensuring transparency. So when we say trust, we are adding explainability framework so that there is a trust in the prediction from the AI. So we are making the calculations and the predictions more open to the user. So it is not like hiding any information. So it is a trustable thing. So actually, this is a real-time result which I produced from the uh, models. So the accuracy between both models. So it finally it says that light GBM is having the more positive values. When we say AUC value, so it is 0.9999. So the timing, when we say timing, no, so the light GBM takes more time than the XGBoost while training. So not while testing the sample or while predicting the sample. So it takes time for the training. So it won't be a what to say, cost for the users. No? So the training will be done from our side, and the end result only the users will get. So only in this way, light CPM is having disadvantage comparing to XGBoost. So you can see here, analysis revealed key predictors: age, systolic blood pressure, cholesterol, and chest pain. So these are the main cause for the cardio disease. So this is the real-time result. So this is actually a sharp explainability image. So you can see the number of parameters used here. So the most used parameter is resting BP, blood pressure. So it takes what to say, more place, I mean more priority while comparing the other parameters. So we need to look into all the parameters, but the main parameter is resting VP, and then follows as follows. So these are all the explainable images. So based on the age, we have a segregation here. So age-wise segregation, and BP wise segregation, and cholesterol wise segregation. So when we say age, both are similar. So no disease and disease. So it is actually off. Based on the blood pressure, the disease, I mean the patients who are in the data set, no, so the disease is more higher than no disease. So likewise, I've added the explainable image here. So finally, I would say this chart. So 58 percentage of the people is having no disease, and 42 percentage of the people is having disease in the data set which I am using. So this is actually a generated image from the SHAP explainability. So when we say SHAP, no, so it is shapely additive explanation is an explainability framework based on the game theory. There is a theory. So what it does, no, so it produces, I mean, it predicts the AI result, and it explains with the various conditions that we asked for. So both models agreed on top of the features, but shows stable differences. So light GBM was more sensitive to extreme blood cholesterol values. So why it matters in the healthcare especially, enhances trust by making AI predictions transparent, ensures clinical relevance by confirming alignment with the known risk factors, helps detect bias or anomalies. Uh, so as I said, anomalies in the sense, so to predict the information that we don't expect. Okay, so there could be unexpected responses. No? So to predict those things, we help. I mean, we use sharp explainability. So this is the image that produced based on this parameters, which is used mostly. So in the XG boost, these three parameters, resting BP, chest pain, and slope is used more. Okay, so this is actually a sharp value which says whether it is positive or negative, which means having disease or not having disease. So if it is negative, no disease. If it is positive, then the user is having disease. So in the BP, you can see if the user's BP level goes beyond 140, it is having positive values. Then if the user's blood pressure crosses 140, they may have heart disease. So this is the prediction. So likewise, chest pain. So the same explainability. So whatever the positive, negative value you see, same applicable to all the images, right? Chest pain and stroke. Similarly, for the light GBM, so we have three parameters which is more important in the data set. One is BP and cholesterol and old peak value. So old peak in the sense it is a value which produced from the stress test. So as I said earlier, no. So stress can cause a heart disease. So the old peak is a stress test. Here also, if the negative value, I mean, the person presents in the negative value place, they don't have any disease. If it is positive, then they have some disease. It is a value. So it is a final summary. So this colors, no, it highlights the disease value here. So if it is blue, then the user is having no disease. If it is red, the user is having disease. So as you can see, the red colors placed in the positive side, which means the negative value is having no disease and positive value is having disease in all the images. So these are all the parameters used mostly for the prediction. So practical impact. So just for the testing, we use any sample data, those things fine. So when we say practical, no? So it is non-invasive early screening. So the disease can be found easily. I mean, before it affects more. So clinical decision support, it helps the doctors to predict the disease. I mean, the AI predicts something, doctors can have some idea based on these predictions. So instead of taking all the tests from the beginning, this prediction will give some idea to the doctors can treat the patient. So personalized risk assessment. So patients themselves can use this model to predict their heart level, I mean, the disease level, whether they are having something or not. So efficient use of resources. Light GBM's fast inference makes it suitable for real-time CHD screening in large populations. As I mentioned in the earlier slides, Light GBM works well with the larger dataset. So then when it comes to a large population, Light GBM performs more better than the XG boost. Okay. So trust and adoption. Since we introduced the sharp explainability and aligning predictions with the known medical risk factors, not the like a complicated parameters, the BP, chest level, I mean chest pain level, slope, old peak. These are all common values, so users can trust based on their values actually. So looking forward, this is actually a first step in my research. So this is not a full solution that I would say. So it is a first level, and I need to look into unstructured data predictions and combine both the things and produce whatever the outcome which helps the user. No? So this is a first step, and my research focus on validating these models across more diverse populations. Since it is an online data set, I need to get the real-time data set to predict and to perform operations with the models and exploring fairness to ensure consistent predictions across demographic groups. So demographic groups in the sense the category should be there. So based on the gender, we can have prediction. Based on the age
Sir,
group, we
please
can have
complete
prediction.
your
So
work.
sorry.
There is a time constraint with us.
Yes, sir. I'm at the last slide. I'll be concluded. So finally, in this review paper, I am saying that light GPM in the boosting frameworks, light GPM slightly outperforms XGBoost with a higher accuracy and other values. And also it is faster in predicting the things also. So this is a review paper. And I will be proceeding further to predict other things. So these are all the references I used. There are more. I highlighted only 5 here. That's it.
Okay. Yes. Mr. Gautam,
Yes, sir.
uh, is light gradient boosting machine always more accurate than XGBoost?
It depends on the data set, sir. If it is a large data set, I would say that light GBM is the best thing. So if we have a minimal number of data, no, so if we take around the 200, 300 samples, the light GBM does not provide you the better result. At that time, you need to go for the
Okay, okay. Thank you. Thank you.
yeah. Thank you, sir.
Next candidate, Chitra Gautam.
Yes, sir. Am I
Chitra
audible?
Gautam. You have 10 minute slots and conclude within this time frame. So you can start.
You can
now.
start.
Sir, is my slides visible?
Yes. Yeah.
Okay. Good afternoon, everyone. My name is Chitra Gautam, and I will be presenting my paper, Unveiling Metaverse in Education, a Text Analysis Perspective, co-authored by Dr. Ganesh Chandra. So this will be the agenda that I will be covering in this presentation. I will start with the introduction to the topic, then we will move forward with the research questions, the data collection and the methodology, and we will see the key findings and the implication and conclusion of our findings. So now let's start with the introduction. So we have seen that metaverse is gaining a lot of popularity these days. And the metaverse concept is gaining a lot of huge buzz in the research domain as well as in the industry. So if we look at the history, the metaverse concept is not entirely new. It actually first appeared in 1992 in the sci-fi novels such as Snow Crash. And it was widely recognized afterwards in the platforms such as Second Life, and it became immensely popular in the multiplayer online role-playing games of World of Warcraft. And it has captured a lot of interest by the youngsters. So it officially gained the buzz in 2020-21 when Mark Zuckerberg officially announced the Metaverse project in October 2020-21. So if we look at the formal definition, Metaverse is a virtual world with a shared 3D virtual spaces operated through multiple virtual tools like our real and dynamic world. It is a digital world where everything would be online and in an immersive 3D-like environment. And if we if we look at the Google search trend results from the last 5 years, we can see that Metaverse is also gaining a lot of popularity. Because of the popularity, the educators and the researchers began to explore the future agendas and implementation scenarios for the learning practices. If I take an example, suppose I have to explain the solar system to a class. So it would be better if I explain it in a virtual environment where people can experience the galaxy and they can feel the planets moving around themselves. And therefore, the educational landscape have witnessed a surge in interest driven by the metaverse and the virtual reality. But when we looked at the literature, we found that despite the increasing interest in the metaverse, the term is relatively new, and there is a need for examining the state of art in the metaverse research, specifically in the education sector. And also we found that there is no study that captures the public's perspective, discussions, and the concerns related to development of metaverse in the education sector. So to fill this gap, our study answers the three research questions. The very first one being, how has the concept of metaverse in the education has been understood and put into action? The second one being, what are the most common themes and topics related to the metaverse in the education sector? And the third one being, do the themes identified through our analysis correspond to the dominant topics and research areas discussed in the academic publications on the metaverse education? So if you look at the data collection and the methodology, we found that the news articles are a crucial method for spreading the awareness about the new technology that shape the discussion and influence the adoption decisions. It also helps researchers stay updated on the latest technology trends and to gain the insights from the industry and the public sentiment and the competitive activities that are going around. So therefore, we collected the news articles through the web scraping method by using Python libraries. And we gathered data from the weekly publications, the Economic Times and Financial Express. So after screening our data set, we found that 120 articles were identified as relevant that are talking about the metaverse in the education sector. Further, to validate our findings, we utilized 311 journal articles that talk about metaverse in the education sector from the Scopus and the Web of Science databases. Coming to the methodology, we adopted the very popular text analysis method, that is LDA method, for the thematic analysis to identify the top themes. We also made the co-occurrence network graphs using the software's WAS viewer to analyze the text and identify the major clusters that are formed around the words that are highly appearing in the news articles.
सर
And furthermore,
सर ये जैसे शुरू हो गया है तो जैसे इसमें इनका जूम बन के आ रहा है इसमें इसमें
uh,
शेयर करके जब आएगा
so we also did a comprehensive review of the journal articles that we have collected. Now, coming to the key findings, we made the word cloud from the news articles and also from the research articles that we identified. We found that there are similar findings and the keywords that are appearing are highly correlated, such as the terms such as technology, virtual, digital, virtual reality, skill, India, and these are the words that are highly constantly appearing in the text. So it shows that the metaverse is gaining popularity in the education sector, and people are talking a lot about it and discussing about the implications in the education sectors. Now, moving towards the topic modeling results, we identified that there are 5 major topic clusters that are coming from the news articles. If you look at the top 30 relevant terms that we found from the topic 1, we found that the terms such as students, education, digital, skills, technology, these are the words that are very relevant in this topic, and therefore we clubbed these terms and made this one in under one topic, named as the future of education in the metaverse. So in this topic, the articles talk about the core concepts and principles of metaverse to be integrated in the education sector, and it highlights the potential for engaging the interactive learning experiences in the metaverse education, and also emphasize the role of technology and artificial intelligence that can be included in the metaverse for enhancing the education experiences of the students. Coming to the second topic, we found that the keywords such as virtual, digital, education technology, that is edtech, teachers, content, are immersive. These are gaining a lot of popularity in this, and this talks about this topic talks about how the students prepare for the evolving job landscape through the metaverse-based learning. It highlights the exploration of new teaching methods and approaches enabled by the metaverse. And the articles here are talking more broadly on the context of metaverse in education within the digital transformation of the education sector. Now, coming to the topic.
Your final conclusion slide.
Coming to the third topic, here the keywords such as world, reality, experience, technology, India, and these kind of words are getting a lot of occurrence. So this topic talks about the focus on the specific challenges and opportunities for implementing the metaverse education in the Indian context, and it highlights the potential for the personalized and adaptive learning experiences in the metaverse education sector.
Chitra Gautam, come to final conclusion slide.
So, yes, sir.
Come to your final.
Conclude your work.
Conclude your
Yeah,
work.
yes, sir. Sure. So it emphasizes the use of metaverse to promote the education sector. So similarly, we have five keyboard topics that also focus on the applications and the impacts of virtual reality in the metaverse learning environment and the practical reality and long-term effects of metaverse in the education sector. So if I conclude my findings, we see that there is a rising interest of metaverse in the education sector across diverse academic disciplines that promote the skills and learning experiences. There is a shift from potential exploration to tangible applications such as promoting collaboration, gameful learning, and virtual experiences. Uh, it is uh, it is seen that researchers are fostering a learner engagement, motivation, and development of 21st century skills like critical thinking and problem skill. And if you look at the challenges that can happen in this integration, that is data security, learner addiction, emotional and social barriers, and the ethical consideration. And if you look at the future research direction, it shows that there should be optimization of curriculum design, there should be learner support and ethical consideration while integrating the metaverse in the education. That's it from my side. Thank you. Yes, sir. Any questions?
Can you elaborate the meaning of STEM you have used in your conclusion?
What, sir? Hello?
You have mentioned STEM, STEM.
Yes, sir. Yes, sir.
What is that?
Sir, that's a acronym for science, technology, and management. Mathematics, sorry.
Yes, rising interest of metaverse in education, no?
Yes, sir. Yes.
In physical education, is STEM.
So STEM is an acronym for science, technology, engineering, and mathematics. So it talks about that metaverse is gaining interest in these domains, that is science, technology, and the engineering and mathematics field as well.
Okay. Thank you.
Has any question?
इसके बाद ना हनुमान मौर्य.
Next, Hanuman Maurya. Hanuman Maurya.
Are you there? Next. Kamran Ahmed.
Ashwini.
Ashwini, I am here, sir.
सर आवाज आ रही है? हनुमान मौर्य आवाज आ रही सर?
No, sir, I am Ashwini.
Hanuman Maurya,
Kumar.
हनुमान मौर्य जी.
सर हनुमान मौर्य आवाज आ रही सर?
You can present your work after Ashwini Kumar. First, Ashwini Kumar will show.
Good.
Okay, sir. Okay.
Okay, sir. Good afternoon, sir. Myself, Hanuman Maurya. Our topic
Hanuman Maurya,
is.
you can proceed.
जी सर.
Hanuman Maurya, you can proceed.
Ashwini ji, after him, you can proceed.
Okay, ji. Okay, sir.
Okay.
सर हनुमान मौर्य सर.
Yes, you
आवाज आ
can
रही सर?
proceed. You can proceed with your presentation.
जी सर. Okay. Good afternoon, sir. Myself, Hanuman Maurya. Our topic is the attention guide
Make your
multi-stage
screen
hybrid
full.
models for
Hanuman Maurya,
enhanced.
make your screen full.
Yes, sir.
Make your screen full.
ठीक सर, ठीक सर, ठीक. Detection and segmentation of the radiography. Introduction. Dental caries is the chronic disease affecting the billions words. Early diagnosis prevented the tooth loss and the reduced the cost of the treatment. Traditional diagnosing manual examination of the radiography, slow subjective phone and the human error. Deep learning is enable the automatic, the consistent of the high accuracy diagnosis. However, currently deep learning models suffering from the noise sensitivity, regularity boundaries, and the poor generalization across the graph. Research gap. Base model net RES net 15 classification RES net UT and the segmentation challenges the Poissons and the pulse noise of the dental radiography reduced signal to noise ratio, carries bounded in the regular and fuzzy making the segment difficulty. Model trained by on the radiography Bite wing do not generalize their others, panoramic and the periapical. The need of the unfied pipeline, the combination of the advanced noise detection, attention guideline feature the learnings. Objective. The proposed AMSHA addressed in the limitation by the introducing 3 मॉडल्स हम लोगों ने यूज किया था है ड्यूल स्टेज de-noising models, hybrid attention net models and cascaded attentions. रिसर्च सर्वे रिव्यू किया. Proposed models multi-stage hybrid models methodology proposed combined in the 3-stage pipeline the robustic carrier detection methods. To start the dual-staged de-noise models is the combination of the non-zero limitations and the adaptive filter medias of the residual noise. The hybrid attention net models, which can be the extension of the net 15 and enhanced by the additional of the especially and the channel attention of the classification by the correctly. Usually the cascaded attentions combine nest skip and the unit with the attention gate to the lesion segment. ये मेथोलॉजी हम लोगों ने मेथोलॉजी यूज किया हम लोगों ने हमने सिग्नल फ्लोचार्ट बनाया इसम का. Propose and noise reductions, radiography correct by the poisons and the impulse ratio, adaptive soft switching median filters, layer division and the non-zero eliminated methods, attention mechanism enable methods in the focus on the silent regions, channel attentions, spatial attentions. Proposed models, pipelining, DS, DM and the HR15 and the CA cascaded models handle the noise, improve focus, enhance and the boundary delimitation, delineations, dual stage noise. एल्गो हमने लिखा है. Hybrid attentions enhance the standard reset net 15, the channel attentions, spatial attention combined effects, cascaded attentions, integrated 3 innovations of the segmentations, preactive, dense and attention gates. Outcome में आ गया accurate pixels wise segmentation of the irregular and the physically lesions. Dataset में large scale dataset 20,000 any data. Expert provided the pixels and the illumination and itna prevent wide width 70% validations prevent. Implementers details hardware हमने लिया video and 100% graphical unit elevation matrix analysis. Classification task accuracy sensitivity specificity. Segmentation task में this coefficient intersection over union pixel wise the accuracy precision and the recalls. These metrics ensure the comprehensive assessment of the both classification and segmentation performance. Evaluation study results. This proved that the additive and the synergy effect of
Hanuman, conclude your work. You have only 2 minutes left.
जी sir.
Conclude your work. You have only 2 minutes left.
जी sir. This paper presented by the AMS is the novel deep learning pipeline for the automated the dental caries detection and the segmentation by systematically addressing limitation related to the noise features, selective and the boundary ambiguities. SMS achieved the new state of the art performance demonstrating high robustness and the clinical ability. In future, we can propose the model of the incorporate explain AI/XI techniques to provide the visual explanation and the method and models and the predictions, thereby the increasing the trust and the adaptation of the among dental professionals. Thank you, sir.
Have you used fuzzy set in this regard?
Yes, sir.
fuzzy, have you used fuzzy rules?
फजी रूल सर अप्लाई किया गया जो 0-1 के बीच में होता है, जो हमारी जो हम डेंटल कैरिज हम बेसिकली हम काम कर रहे हैं सर डेंटल कैरिज पे। डेंटल
Okay,
कैरिज को
okay.
छह को देख
So
रहे हैं
have
सर।
you defined some membership functions here?
जी सर,
Membership functions
सर
in the fuzzy rules.
इसमें सर,
Okay, fine.
इसमें सर,
Okay, thank you. Next,
okay,
Mr.
okay.
Ashwini Kumar.
Okay.
Mr. Ashwini Kumar, you can present
Yes,
now.
sir. Yes, sir. Yes, sir. Now I'm presenting.
You have only 5 minutes to conclude your presentation. So
Yes, sir.
be within
Yes,
your
sir.
time limits.
Yes, sir. Sir, good afternoon. I'm Ashwani Kumar. Today I'm here to present my research paper titled A Study of Agile Software Development in Cloud Environments Using Scrum and
Make your
Kanban
screen
Practices.
full. Make your screen full. So in the slideshow.
Okay, sir. Okay. Yes, sir. Is it visible?
Yes, but screen is not full right now.
Sir, this is full. So,
Keep it in the slideshow mode.
okay, is it visible, sir?
You can proceed.
Okay, sir. So, my paper is a study of agile software development in cloud environments using Scrum and Kanban practices. So, my article demonstrate ADCC framework, means cloud computing plus agile model. So, in agile model, there is a flexible model. So, software development requires to adapt dynamic. In agile model, at any time we can change software requirements. So cloud computing also multi-tenancy environment. In cloud computing, agile model is fulfill its all of requirements. So I'm looking for agility versus ADCC, advanced development cloud computing model. So this diagram demonstrate in software industry 58% Scrum framework is used, 13% Kanban Scrum used, and 9% Scrum Ban is used. 6% XP framework is used, and other is 14%. So my article demonstrate Scrum and Kanban practices. So using Scrum and Kanban, so I'm using Scrum-Ban, means blended approach using Scrum and Kanban. So I'm using Scrum-Ban approach in cloud computing practices. So this is literature review, and yes. So this is results and study. This is a comparison of agile versus ADCC with cloud native continuous integration and continuous development, means CI/CD stacks. So first phase is requirement analysis and planning. So in this, in agile practices, sprint planning, user stories, product backlog into like Jira, Trello. But in ACC practice, agile plus cloud computing means agile hosted, agile boards with integrated pipelines for traceability. Some technologies are there, Azure boards, DevOps means development operations, GitLabs. So two frameworks are there, Jira and cloud. Second phase is design and coding. So in agile model, local development, Git version control, peer reviews. But in ACC practices, cloud-based collaboration, coding, environments, instant code, cloud IDEs. So some IDEs are AWS Cloud, GitLab, Cloud IDEs. Next is continuous integration and continuous development. So in continuous integration, we use CI/CD, continuous integration, continuous development, Azure pipelines. Next is testing phase. So testing levels, unit testing, integration testing, security. But my article demonstrate on A/B testing. In A/B testing, there are two pairs. First one is A and the second one is B. हम क्या करते हैं, किसी मॉड्यूल पे दोनों A/B टेस्टिंग करते हैं, एंड which pair is best, either A or either B. That pair is selected. Next is deployment, means continuous development. So in ADCC model, continuous delivery with cloud, with ops operation, and last is monitoring and feedback. So after every sprint reviews, chartings, velocity takings are there using cloud architectures, Microsoft Azure, etc. Next is conclusion. So my article concludes the ADCC framework is accessed by the conducting a case study. The objectives of this study are detail the obstacles associated with agile software model. जो भी agile software models के अंदर obstacles हैं उनको हम eliminate कर सकते हैं using the ADCC framework. Second one is illustrate the applications of the ADCC framework to address these issues. Okay, sir. Thank you.
Can we conclude? Can we add more approaches in this regard?
Yes, sir. I am using A/B testing and continuous integration and continuous development.
Okay, thank you.
Okay, sir. Thank you. Thank you very much.
You can stop sharing your screen. Next, Sanjeev Sharma. Mr. Sanjeev Sharma.
Hello.
Mr. Sanjeev Sharma. Mr. Deepak. Mr. Deepak, you can share your screen and start presenting.
Okay, sir. Thank you.
Mr. Deepak, time for you to conclude your work is 5 minutes. So be within your time limits.
So my screen is visible or not?
Yeah, you can start now.
Good afternoon, sir. My name is Deepak from Department of Computer Science, IIT Kandahar. Today I am presenting my paper that is based on blockchain-enabled dynamic load balancing in fog and edge computing environment, a consensus-driven decentralized framework. In this slides, I'm going to present about the abstract introduction, objectives of my papers, the problem statement, system model and architecture, challenges regarding to facing in this paper when we are implementing the blockchain technology. And the last one is conclusion, features of references. We talk about the abstract about this paper. Basically, we are proposing a framework with integration of blockchain technology in fog and edge computing environment, how we can handle the dynamic load balancing in the fog and edge computing environment. For this purpose, we use some consciousness algorithms, for example, proof of authority and practical vendor time fault tolerance. We also use some smart contracts which automatically schedule the resource allocation to enhance the functionality of this model. And finally, in this paper, we are trying to contribute a better scalability, decentralization, and context awareness to load balancing while improving fairness, accountability, and security to the forward ecosystem. The second slide, which is representing the introduction of the part. The main thing is that why this problem has been arise and why we are need to use the blockchain in the field of load balancing in fog and edge computing environment. The reason behind all is the growth of the IoT devices. As IoT devices are increasing, they are also increasing the lot of data, and due to this, low latencies arises. So this paper basically focus on the improve the low latency, make it strength, and so many quality of service parameters. So in this paper, we are trying to solve the some computational capacity that are closer to the users and sources of data, and as in for computing. So they help to reduce the latency and cut down the bandwidth of requirements. Using this technology, we are addressing challenges by facilitating decentralized, transparent, and trustless coordination of distribution nodes. And this paper basically explored the potential of blockchain in fog and edge computing to create an autonomous system that maintains security, scalability, and fairness. As we already discussed, we use some blockchain tech methods like proof of authority and PVFT, that is practical vendor time fault tolerance. Basically, this method used for the high throughput in blockchain technology. These are the objectives of our paper. The primary objective of this paper is to design a blockchain-enabled dynamic load balancing framework for the fog and edge computing environment. Using this framework, we can achieve efficient load distribution. We can ensure the decentralization and fault tolerance problems. And we also support the scalability for IoT application, as well as in future, we can also evaluate and improve the performance parameters, or we can say that quality service parameters. If we talk about the problem, why we are discussing this problem, the reason behind all this is the screen. So many old strategies, or we can say that current strategies in organized computing environment, they are only heavily rely on the centralized system. They are not decentralized. If centralized system is filled, whole the system will be filled. So we are trying to develop a framework that is decentralized, and in any case of problems that should not be corrupt, or that should not be filled. So that we are solving this problem, and thus we are discussing this problem. This is the system model, or we can say that architecture of my proposed model. In this framework, basically we divide in 4 layers. The first layer is IoT device layer, and the second is as node layer, and the third one is fog layer, and the last one is blockchain layer. If we talk about the working of this framework, is very simple. The IoT device layer is the bottom layer, which consists of so many devices, IoT devices, and that IoT devices generate huge amount of data, and these IoT devices submit the task to the as node. And after the second layer, after the first layer, the second layer is as node layer. As node layer basically consists of 3 elements, or we can say that 3 components, that is LMA, that is local monitoring agent, which collects resources utilization metrics of the node. The second one is blockchain validator. As node also participate in blockchain consensus that ensure only valid and trustworthy decisions are executed.
Deepak, conclude your topic. Deepak K, you can proceed with your topic. Deepak K.
Yes, sir.
Okay, start your presentation.
Good evening, one and all. This is Deepa. My research topic is a lightweight authentication protocol, LAPHEC, for drone using HEC scheme. To tell about the contents.
Deepa, you have 6 minutes.
Okay, sir. Thank you,
Conclude
sir.
your work in 6 minutes. Okay.
Okay, sir. Okay, sir. To tell about my contents, I have the abstract, introduction, background study, proposed framework, security positions, analysis, conclusion, and the reference. To tell about in precise the abstract, the drones have to be securely connected. Here I have used ECC, LAPHEC, new lightweight authentication protocol, HEC, enhanced security protocol for the computational to be low confidentiality, mutual authentication, and protection impersonation attacks.
Deepa, rotate your phone in the landscape mode. Yeah, now it's proper. Now you can start presenting your work.
To tell about the introduction.
Start from the first slide. Start from the first slide.
From here, sir?
Yeah, now you can proceed.
Good evening. This is Deepa. My topic is lightweight authentication protocol, LAPHEC, for drone using HEC scheme. To tell about the contents, abstract, introduction, background study, proposed framework, security positions, analysis, conclusion, and the reference. To tell about the abstract, drones need secure communication. So here, ECC, LAPHEC, HECC have been employed for the computational confidentiality, mutual authentication, and protection for the impersonation attacks. Introduction. To tell about the introductions, in order to avoid the spoofing of data interceptions for the drone, a lightweight authentication is used here. The new lightweight authentication is the LAPHECC. It is based under the HECC. It is working under 3 phases. To tell about the working structure, this is the user gives the commands to the ground stations as the control to the drone, which is monitored, and the data is processed in the separate information counter. So this is the working diagram. To tell about the background study, already they have a background literature of RFID PUF technology. So these faced many challenges in for a limited processing power of its tags. So here we introduce scheme of HED-HOC, that is the communication between the drone and the ground station. It is passed through a handshake through the message 1 and the message 2, and the confirmation is done by the messages 3 for the message integrity. The proposed framework, it undergoes the design strategies, pre-registration phase, authentication phase, and the session key update phase. To tell about the design strategies, it is pre-registration phase. The drone and the ground stations have the pre-registrations, that is authentication is sent as a request, response, session key update request, new session key is generated, LAPHEC message is transmitted between the drone and the ground stations, vice versa, and the zero knowledge proof is obtained. Finally, it is verified. To tell about the authentication phase between the drone and the ground stations, device identifier is communicated with the public key certificate. Token to drone replies proof of identity for verifications is so that it avoids the eavesdropping, tampering, and replay attacks. To tell about next is the session key update phase. Here, the session key, public key, everything are undergone with the help of the timestamp. The timestamp validity to prevent replay attacks, the session key for secure communication. So here, the data are decrypted, the timestamp is validated, and the proof of verification is terminated. The security position analysis. So it gives a between the LAPHEC, HED-HOC, that is the backward security. It gives the LAPHEC, it is more comfortable. Anti-replay attack protection for both, it is okay. Forward security, it is undergone under both. Session key confidentiality for both. anti-mask attack verification for everything. So the user convenience, it is use the minimized key. To conclude my work, so this is a lightweight authentication protocol for the drones using HECC, zero knowledge proofs for secure and efficient framework. Here, HECC is used instead of ECC. So LAPHEC has the enhanced security, reduced resource consumption, improving battery efficiency and quantum resistance. The mutual authentication, session confidentiality, integrity, key exchanges are well done. Key updates with backward, the most advantageous is backward secrecy for drone networks. So these are my references and I conclude my work. Thank you so much for giving me this opportunity.
Thank you, Deepak. And next is Kamran Ahmed.
Sorry, sir, I couldn't get you.
Thank you, thank you.
Oh, thank you so much, sir.
Next is Kamran Ahmed. Are you there? Sanjeev Sharma. Paper ID is 196 from MJPU. Then K. Ramaya. Paper ID 482. Are you there? Paper ID 168. Divya K. Are you there? Am I audible to all of you? Okay. Then Mansi Yogesh Sudhankar. Are you there?
Hello.
Yes.
Yes, sir, I'm there.
You can start your presentation, madam.
Okay, sir. Thank you. Okay, sir, am I audible? Hello.
Yes, you are audible.
Yes, sir. A very good evening to all the respected dignitaries, fellow researchers and attendees. It gives me an immense pleasure to present my work titled A Deep Learning Based Multimodal for Continuous Authentication Using Face and Iris Biometric. Myself, Mansi Sadhankar from Department of Electronics and Computer Science, RTMNU Nagpur University. And this work has been carried out under the supervision of Dr. Ashish Sasankar, Principal of Indraprasth Niwas Commerce and Science College, Wardha. So in this presentation, I will be explaining the motivation, methodology, experiments, and estimated results and future direction in our research, proposed research system. So this is the content of the paper. So the next slide is about the introduction. So authentication essentially answers the question, are you really who you claim to be? So in this modern digital security, there are four major categories of authentication. Knowledge-based, this includes something you know, like password and paraphrases. Possession-based, it involves something you own, like smart card, hardware tokens, or mobile devices for SMS-based OTP. And the third one is biometric. Here we rely on something you are, like our fingerprints, facial recognition, iris, retina. And after that, fourth one is the multi-factor authentication. That is the combination of two or more categories, say a password plus a fingerprint. So this will significantly enhance the security and is becoming the standard for security system. So what is the problem with the traditional authentication systems? That the traditional authentication has a weakness that most of the system only checks the identity once at the start of the session, and after that the system assumes the same user remains throughout. So this is a dangerous scenario since imagine you log into your laptop and walk away. Even though you authenticated, someone else could misuse the system in your absence. Similarly, if malware compromise your device mid-session, traditional methods can't detect it since there is no continuous monitoring. So the gaps are one-time validation, session vulnerability, and non-continuous tracking. So this is where the continuous authentication becomes important. It ensures the system keeps checking identity periodically. So why we have chosen face and iris biometric only? So face recognition is easy, non-intrusive, and the it works with standard cameras already present in laptops, smartphones. But it has one weakness, that it is prone to spoofing and performance drops if the person wears sunglasses or a mask, or if the lighting conditions changes. And next one is iris recognition. So this is the most accurate biometric. The iris texture is unique even between twins, and remains stable over a lifetime, and it gets less affected by the aging factor or the environment. Hence, it requires more controlled imaging conditions. We have chosen face and iris recognition here. So this is the research gap. When I have studied this research gap, I have found out the major gaps in between in these papers is that temporal continuity or user experience means most existing systems still treat authentication as one-time event. They don't continuously verify identity, nor do they balance user convenience with periodic checks. Second one is adaptive reliability and drive acquisition. Fusion methods rarely adapt to changing conditions. For example, if lighting makes facial recognition unreliable, the system should give more weight to iris, but current systems don't handle this well. And the last is the deployment-driven validation, where many works are tested only in labs, not in real-world conditions like variable lighting, device constraints, or cross-dataset scenario. So, addressing this research gap is crucial, and for developing robust and deployable CMBA is a really important concern here. So this is the summary of prior work versus this work. So in early work, especially between 2012 to 2015, focused on hardware prototypes for face iris fusion, but they did not consider continuous or periodic authentication. Other works looked at behavioral biometrics like typing or mouse movement for continuous tracking, but without multimodal fusion. They didn't use multimodal fusion, means combination of two or more biometrics. Recent study, that is from 24 to 25, have fused multiple triads like face, fingerprint, ECG, or gaze, but these were offline and one-shot system. So our contribution is unique. We propose a live system with face iris fusion, adaptive scheduling, and periodic re-authentication, filling the gap left by the prior work. So this is the CMBA framework design and objective. So first is enhanced security. By fusing two biometric modalities, spoofing becomes much harder. Then next one is improved accuracy. Deep learning models ensure high accuracy in recognition. Real-time processing, this system works in the background seamlessly. You don't need to again and again tell that system to authenticate the particular user. The user will be authenticated regularly by the system during a time interval. Scalability means it can be deployed across different domains: education, healthcare, corporate, etc. Second, and the last one is smart attendance. So an added benefit is automotive attendance tracking in classroom or offices can be achieved through this. The next slide shows the authentication security gap. So the security gap lies in the session itself. The traditional authentication is strong at login, but weak during the active use. So our solution fills this gap by continuously monitoring user. By combining face and iris through adaptive score fusion, we ensure robust session long protection. And this makes the system resistant to spoofing and
Mansi,
adaptability. Yes, sir.
conclude your topic.
Okay, sir. So should I go to direct a proposed methodology or to the result?
No. Conclusion topic.
Okay, sir. So these are the stages: acquisition, pre-processing, normalization, deep feature extraction. Then this is the experimental framework, dataset used, and infrastructure which is required here. So the performance evaluation metrics are accuracy, false acceptance rate, false detection rate, equal error rate, and those are the training validation protocols. So how the system will monitor is it will monitor the user every 15 minutes with time-based scheduler. And the biometric modalities that I will use here is face and iris, where face for face we will employ RESNet 50, and for iris deep IrisNet. Fusion mechanism will be based on neural network based score level fusion. Cosine similarity and learned adaptive weights will be used for matching strategy. And the results and discussions, sir. The result which I have given here, this is the estimated outcome of our proposed methodology, where we are going to combine the two biometrics. So when we consider the previous papers, where when we consider a single model, a single biometric model, and when we consider combining these both iris and iris and face biometric, so the result which we get is far much more better. And one more thing is there, that we can achieve high accuracy, that is 97 to 99%, because even if one kind of authentication fails, the other tries to authenticate the user. There can be any reason for failure of one authentication, but other tries to authenticate the user. So the accuracy here is 99 to 99% estimated one. And so enhanced security and robustness. So liveness detection will be included here. Environmental resilience, anti-spoofing defense. So the future scope is additional modalities we can include in this, like voice or fingerprint, diet or behavioral biometric beyond traditional face and iris. Then multi-tried fusion can be employed here. That's it, sir. Thank you.
Hello. Good evening, sir.
Right, this conclude I'm audible?
Yes.
Hello.
Yes, sir.
Hello.
Sir,
Due
shall
to
I
some
start,
network
sir?
problem,
Yes, sir. Sir, shall I share my screen? Good evening, sir. Am I audible?
Hello.
Shall I share my screen, sir? Good evening, sir. Am I audible? Shall I proceed, sir?
Yes, yes, you are audible.
Okay. Myself, Divya, research scholar from Don Bosco College. Today I will present my work on image-based skin cancer classification and stage estimation using machine learning algorithm. Introduction. Skin cancer is one of the most common cancer worldwide spread. Among all types, melanoma is one of the deadliest. Early accurate diagnosis is critical for saving the lives. However, the correct diagnosis method like biopsy and dermoscopy are time-consuming methods and prone to the human error. So, using new and strong automated non-invasive systems such as a machine learning algorithms, my research objective is to the main objective of my research is to develop a system that can classify skin cancer and estimate its stage using the image analysis. To do this, I extract the important features such as a diameter, circularity, asymmetry index, and entropy. Then I compare them with the three machine learning classifiers such as SPM, decision tree, and KNN, and then evaluated them using a accuracy, precision, recall, F1 score, ROC, and AUC. Related works. Deep learning methods like CNN have shown excellent accuracy, but they have a very low data set and high computational power. Some others are the traditional machine learning algorithms, such as a lightweight factors and more expandable. So, the existing study shows a gap. We still need an efficient and explainable models that can perform well even in a more critical settings. The research gap between this a work focused proposal system. I used ISIC dataset, which has over 10,000 demoscopic images. Process includes several steps. First, the image acquisition from a dataset. Second is to pre-process the normalize and enhance the image. And third one is to segment to detect the lesion boundaries. And fourth one is to feature extract and calculate the diameter, circularity, asymmetry, and entropy. Then classify them using an SPM, decision tree, and KNN algorithms. The performance evaluation for the standard metrics. For example, the feature method might look like a diameter 25.6, a circularity is 0.72, and asymmetry is 0.35, and entropy is 4.82. Finally, the classifier predicts the tumor type on the stage. In methodology, there are 6 methods: after image acquisition, pre-process, after pre-process, segment and feature extraction and classification, after space comparison with the performance evaluation. So the algorithm can be used for using the feature extraction. I have made a comparison with 3 algorithms on the measure of reducing a maximum interior distance between the lesions and the boundary, where the large diameter is advanced and it is a medium to moderate stage, where it is small, it comes to a starting stage. Circularity is close to one round shape. Asymmetric index is over the overlap of the half-face and lesions sit across the vertical and the horizontal axis. The entropy is the randomness of the formula is H is equal to on the higher entropy is the malignant measures. Classification workflow. The classification workflow the research shows that the feature based on the ML machine algorithms, the feature vector of forming using a diameter, circularity, and asymmetry. And the 3 models are used: SVM for the hyperplane for separation, and decision tree for holding the branches, and KNN based on the majority of the nearest neighboring boundaries. For predictions, I have used a tumor type plus stages. And feature is provided using a performance evaluation. So workflow. First, I took an image, made the pre-process. After pre-processing, features has been extracted. After extracting, I made a classification with 3 machine learning algorithms and made an evaluation of best making feature extraction methods. The research shows that the feature extractions based on the ML models are robust and computationally efficient. These achieve accuracy comparable to the deep learner, but requires a far fewer resources. Suitable for a real-world clinical environment, especially in places with computational power. However, they are more explainable where the doctors can understand why the system uses a certain result. So the data set which I took and make a pre-processing, the original image, grayscale image, contrast sketching, and noise removal image. So the picture extracted results, I predicted the result as a 4, it has a very large tumor. The experimental setup. The future work I plan to expand is to the research for the accuracy, SPM, ROC curve, accuracy metrics, ROC curve, and the training time. In conclusion, my research proposed an efficient machine learning-based system for a skin cancer detection and stage estimation. By extracting the features like diameter, circularity, asymmetry, and entropy, the system classifies the cancer with a good accuracy. Among the classifier, SVM achieves the best result of 87% of accuracy in ROC with 0.927. This work has been a strong potential to support the early detection and clinical decisions. The future direction I have planned to work with the CNN plus machine learning algorithms, the SVM, to develop a real-time data, collaborate with the demostopical and clinical validation. The conclusion is potential for early detection and clinical decision support. This was the reference which I have gone through. Thank you.
Devika, there is one question from my side.
Yes, sir.
How to measure your tumor diameter?
So using a formula, sir, based on the diameter of the image, when it is lesser than 2, it comes under a lower ratio, it's greater than 2 or 3, it is in a moderate. When it goes to 4, it is in a high percentage of accuracy in the tumor.
Okay, this is from my side.
Okay.
I would like to invite our next session chairperson, Dr. Parul. Dr. Parul will be connected with us online. Dr. Parul is an assistant professor of Amity University of Lucknow. She has 18 years of teaching experience. Her research interests NLP, web mining, deep mining, IoT. She has published paper in Scopus and other indexed national and international journals. Our second chairperson is Dr. Satyabhushan Verma. He is working in assistant professor in University of Lucknow. He hold a PhD from the NIT Durgapur. Her specialization field is biometric security, blockchain, cyber security, IoT, and digital imaging process. I would welcome to both of them for our technical session.
Okay, thank you. Next candidate, Amaya Varambam. Okay. Paper ID 298. Paper ID ICF 25298. नहीं है. Second group. Paper ID 184. Rahul Garg. Are you there? Dear Rahul Garg.
Yes, sir, I am there.
You can
Good
start
afternoon,
the
everyone.
presentation.
Yes, sir. Okay, definitely, sir. Thank you.
Share slide. Okay.
I hope my screen is visible.
Yes, yes.
Hello.
Yes. The screen is visible.
Hello. Am I audible, sir?
Yes, you are audible.
Just a sec. Am I audible, sir?
Yes, please continue. You are audible.
Yeah. Thank you. Okay. Yeah. My topic for the presentation is methodology of text summarization in low resource languages like Punjabi language. These are the contents which we are going to discuss in this presentation, like introduction, applications of text summarization, major challenges that we face in text summarization, various approaches, work done till date, specifically work done in Punjabi language, various data sets available, various pre-processing techniques, and example, and the conclusion. So what is text summarization? Text summarization defined as a process in which we condense a given text, like we have a text of 3 or 4 pages, and we want to know its conclusion, its meaning, by not reading that much of context. So that is the major role of text summarization, in which we can get the meaning of that text quickly. That will save the time and efforts. So text summarization of two types, like extractive and abstractive. It is basically categorized by how a summary generated by machine is relevant and it is close to human man-made summary. Like in extractive summarization, what we are having, in this methodology, important sentences are extracted by the system, and those sentences are presented as a summary. But in abstractive, system does not get only important sentences, but also it recreates the sentences. In extractive, it doesn't recreate, but in abstractive, it recreates the sentences. It recreates the sentences and generate a summary similar to human or man-made summary. Next is framework that we use in text summarization. There are various techniques, various we can say steps that we have to follow for generating the summary. Like given text is pre-processed. In pre-processed, we are having further few steps that we have to do so that text we give to the machine, we input the text in the machine, that is a clean text. Then a feature extraction is done. There are many steps, there are many techniques through which we can allocate weights to the sentences, that this sentence is important, we have to get it into the summary, or we have to use this sentence. And then sentence classification using AI models so that summary can be generated from the given input text. Next are the applications. Why do we need text summarization? What is the need of text summarization? News articles. There are very good editorials available that are of a lot of text is available in that. So by not wasting the time so that we can get a proper we can say meaning of that. So we need text summarization like newspaper, opinion or sentiment, book summarization, stories, novels, emails, legal documents, scientific papers. Like we can say today's era of digital marketing, we can say digital era. On social media platform, we also we can say earlier on Facebook, we used to upload a tweet or a message of 1 or 2 lines. But in today's, we are uploading a message of, you can say, a paragraph. So what user wants to say, what user wants to convey the meaning in that. So we need text summarization. Various challenges that we face in text summarization. Identification of the most important and relevant information is the most challenging task. Like we have to identify what the importance of the sentences, like which sentence is most important, so that we should get into summarization. Summarization should not be document specific or type specific. Like what we are creating an algorithm that will work only for news articles, but it should also work for social media posts, research articles, editorials, or various other other documents that are available. Third, where we can say challenge is availability of textual volume. Like we can say a machine learning model or a model should not summarize one document. It should be multi-document. Like it should summarize a huge amount of text as well. Summary should be cohesive. Like it should represent the original meaning of the text. It should not be like it is generating anything else. It should convey the summary should convey the original meaning of the text. The most challenging task is generation of abstractive summarization. Like in extractive, we can get the important sentences, assign them weights, and present them as a summary. But in extractive, machine learning model has to generate the text by maintaining its original meaning. So it's a very difficult task. And the most other task is development of evaluation matrices. Like how can we evaluate that the generated summary is accurate and it is relevant to the document. So these are the major challenges that we are facing in text summarization. Types of text summarization, like I earlier discussed, it's a single document, multi-document, generic, domain-based, abstractive, and extractive. These are the state-of-art work done till date. Like we can say, people who have done abstractive summarization, these are the work done by other researchers. This is the work done by researchers in Punjabi language specific. Like I am working especially in Punjabi language. So these are the approaches that researchers has already implemented in Punjabi language. Only a single machine learning algorithm PSO has been implemented yet in Punjabi language. Otherwise, various users has used SVM or they have created a list of entities, name and persons, or they have presented some algorithm that can delete the irrelevant articles from the text. And these are the various data sets available, various models and data sets available for machine learning. These are some pre-processing techniques. Like I would specially discuss the pre-processing techniques because these are very important for cleaning the text, especially in low resource languages where diacritics of the text are connected with the alphabets. Like we can say in English, we use directrix like a dot, which is not connected to the text. But in Punjabi or Hindi, our diacritics, our matra are already connected to the text. So we have to eliminate, and it is a very difficult task to identify and eliminate those. Like we have sentence tokenization. Here we use commas and bars and categorize the sentences, then removal of punctuations. We all remove all the punctuations available in the text. Then after sentence tokenization, we use word tokenization. We convert the sentences into words and by removing stop words. Now we remove stop words like hai, oho, naal, ate. There are various stop words in Punjabi language that we eliminate so that because these are repeated words and this will create issues in our summary. Then word stemming. We have to remove the various infections or derivations of the forms like munda, munde. So it should be converted to its parent form like munda. We will not use munde, mundea. These will create problem in our machine learning model. And example of this summary, like what I am using is this is a summary and this is the main text and this is the summary generated by my machine learning model. And at the end of this presentation, I will definitely say a lot of work has to be done in Punjabi language and there is a need of development of robust system. Some machine learning models by using graph-based algorithms, machine learning models, so that and a benchmark data set is also required to be created so that researchers can create few machine learning models and development in low resource languages of text summarization can be done. Thank you. Any questions?
Rahul, there is one question from my side.
Yeah.
Have you implemented any machine learning model on Punjabi language?
Ma'am, I am
For that,
currently working on the machine learning model. Actually, I have done pre-processing. Filhal, I have completed pre-processing techniques and I have cleaned my
okay.
text. But I am going to implement Indic BART model. I am working on it so that summary can be generated. I am working doing PhD in this.
Okay, fine. So have you performed pre-processing using some automatic tools, or you are doing it explicitly by your code or using some other libraries of
I am
natural language
actually
processing?
for Punjabi language, nothing exists. So I have, like we can say, I have created a list of stop words. I have created a list of
Yes, yes,
names
that
and
is why
entities.
I'm asking to you.
Yeah,
So,
I have actually few lists were available. Lehel sir has created a few lists. Like Punjabi,
yes,
in Punjabi University, Dr. Lehel has created and Dr. Vishal Goel has created a few lists.
yes,
I
yes,
have
yes.
enhanced those lists and have created so many stop words, names, and entities. And I'm using that list, and I have also incorporated few words more because those lists were
Okay,
created in 2011, and now
okay,
it's
that needs to be
2025.
yes, yes, yes. That's
So I
quite
am
old one.
enhancing those lists and I have already worked. But
Do
there is
you
no automated model available for it.
okay? And do you have any lexical database for the Punjabi language?
Ma'am, in 2023, Excel Sum has published a database.
Okay, so
In
you are
2020,
using it?
yeah, ma'am, I am using, and I'll be the first person to use it because no researchers have all done any work on it. It was published in 2023.
Okay, okay. Thank you, Rao.
Okay, sir. Thank you.
Can I present also?
Dr. P. Jayapriya.
Paper ID 591.
P. Jayapriya. Dr. P. Jayapriya. Paper ID 591.
Ankita Maheshwari. Paper ID 149. Are you there, student? Okay. Now we will start session 3B. We should be started from 4, but we are starting now. The first is paper ID 186, Roshan Kumar Raj Ambedkar.
Sir.
Are you there? Paper ID
Yes, sir.
186.
Yes, sir. Yes, sir.
Okay. Roshan, share your PPT.
Good evening, madam. Good evening, sir. I'm Roshan Ambedkar from Nagpur, Maharashtra. My paper topic is prediction and evaluation of COVID-19 in pandemic using LR, RF, SVM, and LSTM. So, as you all know, COVID-19 created a global health crisis in the world, and ML machine learning provides the effective tools for pandemic prediction and analysis. It helps understand the disease spread, mortality, hospital capacity, and support the decision making and resource allocation. So the main objective of my research and also my research paper is we are.
ಇಲ್ಲ ಸರ್ ನಾವು பார்க்கல சார் நான் அதை வீட்டுக்கு வந்துட்டேன்
COVID-19 pandemic by COVID-19 by using machine learning techniques and perform the prediction and evaluation. It will help that the country to get prepared live what's coming.
இன்னைக்கா சார்
Hello.
நாளைக்கு கொடுப்பாங்க சார் அவங்க கொடுப்பாங்க சார் அவங்க
That may help in saving.
Proposed
research develop the model used for prediction and evaluation COVID in terms of the diagnosis of the COVID-19 cases across town to state and national level. And the second one is the transmission of the infection and growth of COVID-19 cases. And also the next analysis and evaluation of the recovered cases, death across the town to state and national level. Overall evaluation and possible forecasting for effective management of a pandemic. I'm just taking a topic in the COVID-19. Recently, you all know the COVID-19 pandemic was and also the main research methodology used in my research is the process of gathering, pre-processing, modeling, and training, and testing of the data. The research uses the 4 well-known machine learning algorithms, that is linear regression, random forest, support vector machine, long short-term memory, that is LSTM. The model were selected due to their applicability in time series forecasting, classification, and the regression problem in modeling of the data. So when I research in this my topic, so I collected data from open sources such as the WHO, and also collected from the local healthcare center. And the data set contains the confirmed daily cases, death, recoveries, testing level, and vaccine level for several nations spanning over time. So when I was collected data, and the pre-process step includes the dealing with the missing values by interpolation, normalization of the feature like the cases per 1 lakh populations, categorize variable encoding like country wise, region wise, area wise, district wise, and also splitting a data into the training and testing. So time series windowing for sequential model like LSTM. So that I am as earlier I am said that for machine learning are the basically used in this research. The first one is the linear regression. Linear regression is the basic machine learning algorithm that applied for predictive modeling. Predictive modeling. Linear regression creates the relation between the dependent variable and more than an independent variable. For example, x and xs and yy. So for COVID-19, linear regression can predict the number of daily cases, case number using the population density, past case number, and testing rates as variables. So following are the steps are used in the implementation. So next one is random forest, suppose SVM, LSTM. These are the methods are used in my research. So when I sampled the data set features, so like a feature like a country, date, new cases, total tests, vaccination rate, population density. And also these are the models used in my research, like a data sets, data processing, data splitting, and all for up to future forecasting. So when I was studied the model used in like linear regression, random forest, SVM, LSTM. So some results are evaluated in using some methodologies. So some accuracies are found that. So summary and findings of this LSTM has the best prediction accuracy, but at the increased computational expenses. That is random forest achieve the best balance of the interpretability and accuracy. SVM excels at the risk classification, assisting public health planning. Linear regression is a quick baseline model, but poor performance on the data. So conclusion of this paper is that when I was using the 4 models in this research, LR, RF, SVM, LSTM. So when I check the effectiveness, accuracy, and how quickly it could process the pattern detection in COVID-19 cases. So among all the methods, the LSTM model did the best job of predicting the outcomes, highlights its effectiveness on complex data found in the pandemic data set. So some of the references I was used in this research paper. Thank you, sir. Hello. Hello.
Next candidate, S. Sivaranjani.
Hello, sir.
S. Sivaranjani. Okay. Sivaranjani, your slide is visible. You have 6-minute time slot. In 6 minutes, conclude your research topic.
Am I audible, sir?
Yes, you are audible. Start your presentation and conclude your topic in 6 minutes.
Yes, sir. So my paper is on serverless computing. I'm research scholar and assistant professor. My guide name is Dr. R. Anandi. She's my research supervisor. So my abstract is cloud computing makes revolutionary digitalized services by moving physical servers to on-demand internet resources. So major advantages are cost effectiveness, scalability, and agility. My paper focuses on serverless computing, where developers do not manage services. Code run automatically when triggered, making it simpler and cheaper. So I compare AWS Lambda set, Azure functions, and Google Cloud functions in leading platforms of serverless computing. So these are the architecture. Should I say the conclusion or?
Please explain this.
So this shows the growth of serverless computing, adoption timeline, industry adoption, leading providers. So from 2013 to 2021, with the share price starting around 2015, it reflects on increasing trust and maturity in serverless platforms. Serverless is now embraced globally across industries from startups to enterprises. Use cases span web apps, data processing, IoT, and more. Leading providers like AWS leads the market, followed by Azure and Google Cloud, each offering robust serverless ecosystems. So here I am comparing the cost comparison between execution time, small workloads, large workloads. All providers show similar pricing in small workloads. So if we compare with AWS Lambda set, most cost efficient can be acquired. Google Cloud follows closely. Azure is slightly more expensive. So here linear cost growth, AWS Lambda, Google Cloud Functions, Azure Functions. Here, the three for large workloads maintains the same cost for cost analysis. So in conclusion, traditional cloud computing, faster hosting, higher cost and lower security, whereas in serverless cloud, low operational cost, enhanced security, not idle for long running process, risk for vendor lock-in. So finally, I conclude that it is expected to dominate future cloud-based solution due to its scalability, cost efficiency, and developer agility. These are my reference papers. Sir?
Okay, okay, no question from my side. Okay. Next, please.
Next candidate, Melati S.
Yes,
Paper
sir.
99.
Yes, sir. Sir, as my screen is visible, sir? Am I audible?
Yes, yes, you are audible.
Yes, sir. Good evening to one and all connected here. I'm S. Malati, research scholar of DG Vaishnav College. My paper titled Advancements, Challenges and Future Directions of Intrusion Detection System. Nowadays, the cyber attacks are increasing, so we are in the need to improve our detection and prevention mechanisms. But as the traditional IDS faces some scalability issues, it has high false positives and encryption issues. So while we integrate the ML or AI with the IDS, it gives some adaptability. So as I previously mentioned, traditional IDS struggles with high false positives and scalability, need for adaptive and intelligent IDS capable of handling modern cyber threats. Like in IoT and cloud environments, demand lightweight and real-time detections. These are the IDS classifications, host-based. These are the traditional existing systems. So I guess I need not to explain more. So I have taken the data set. I have taken the simulated data set to get this result. I have done the pre-processing, normalization, and feature selection to reduce the dimensionality and improve the detection performance. I evaluate the performance metrics using accuracy, precision, and recall FN score. The technique used is signature-based machine learning, deep learning, and unsupervised learning. Machine learning to learn the patterns from labeled data to classify normal versus malicious traffic. Machine learning unsupervised models used to detect the anomaly via reconstruction error. Deep learning models like CNN and LSTM used to detect the patterns. Ideas in emerging environments like cloud, IoT, SDN, hybrid cloud edge ideas. There are many environments integrating the ideas to detect the threat. But what are the challenges is they are facing false alarms due to normal variability, real-time detection in high-speed networks, evasion methods, polymorphism, adversarial machine learning, resource constraint in IoT and edge devices. So by using these techniques, I got the accuracy in signature-based. I will mention the result in the next slide. I would like to conclude that deep learning is performing best than other techniques. Here is the result. Signature based accuracy is 88.5%, which is efficient for known attacks. But even though it is efficient for known attacks, it has some weakness like fails with 0-day attacks. Random forest 95%, it has high accuracy, requires training data. We all know random forest is a machine learning model. It is a supervised model. We have to use the split the data into training and testing. So we need to feed more training data. So that is the weakness of the random forest. Then CNN 96.4% accuracy, capture special patterns, resource heavy. The weaknesses resources are heavy. LSTM 97.1% best for temporal data, time series data. Resources, the weaknesses also resources is heavy. Autoencoder accuracy is 92%. The strength is unsupervised anomaly detection, but weakness is high, as I previously mentioned, higher false positives. So according to the results, deep learning is best performance but unsuitable for IoT and edge. Hybrid IDS is best. So even though the hybrid IDS is best, we are facing the high false positive remains an issue. So in my future work, I would like to plan, I need to create some more framework or integrated AI or ML models, like explainable AI to improve the trust and interpretability, blockchain-based IDS to ensure the trust and integrity, sustainable IDS for energy efficient, federated learning for privacy pursuing training, adversarial robustness again evasion. I would like to conclude with IDS is a vital role of cybersecurity. Even though AI and ML are supporting to improve the detection, we are facing some challenges like false positives, scalability, and adversarial threats. In future, I would like to improve with intelligent, adaptive, and ethical, sustainable ideas. This is my I'm a research scholar, so this is my first step of my research. And my domain is cybersecurity, so I have choose the ideas. Now I'm going through the literature review and everything. This is my first paper of this ideas. Thank you. Any questions, sir?
Okay. Okay. Thank you, Malati.
Yes.
One question from my side.
Yes, sir.
How do AI and ML enhance the ideas?
Yes, sir. By using the rules, for example, in conventional neural network or a long short term network or in a random forest, some usual ML models, we can enhance the IDS detection by giving some threshold value. We can basically logistic regression, random forest, SVM are fraud detection methods. While integrating that, how they are detecting the fraud by integrating the rules and rules. They have some certain rules. So by nature, intrusion detection system has the nature to detect the threat. By combining these both, we can enhance the intrusion detection system nature by giving the more advantage by using the AI, sir.
Okay, thank you, Malu.
Thank you, sir.
Next, please.
Okay, next candidate is Sarpriya Adarsh. Paper ID 175.
Yes, sir. Am I audible?
Okay, yes. Share your PPT
Yes,
and
sir.
conclude your research within 6 time frame.
Okay, sir.
Yes, it is visible.
Okay, thank you, sir, for the confirmation. Let me start. Hello, everyone. My name is Sarvapriya Adarsh. I am from Amity University, Lucknow. And my topic is analyzing solutions for copyright protection and attribution in generative AI. So today's talk examines the solution for copyright protection and attribution in generative AI, motivated by systems like Sora, Midjourney, ChatGPT, Stable Diffusion, enabling rapid high-quality creations of images that you have seen. This sets up in a central tension between unprecedented creativity and capability of AI models and legal doctrines governing authorship, ownership, and attribution. So this paper is outlining that. Okay. Uh, so uh, Current copyright and authorship doctrines presume that humans are the creators and leaving AI outputs and legal gray zones with competing claims by developers, users, joint authors, and corporations. Objectives are to analyze the limits of copyright and fair use for AI training, evaluate technical controls such as metadata, outputs, and encryptions, and purpose of actionable reforms and standards. This structure guides the remainder of presentation and frames evaluation criteria for proposed solutions. Okay. So let's start with methodology. This work synthesizes a comprehensive literature review and case studies to map the strengths and gaps of prevailing legal and technical approaches. Scope, spa- spans multimodal Gen AI and representative systems, focusing on doctrines and controls succeed where fail in practice. Findings are used to derive concrete proportional proposals rather than remain purely theoretical. So generative AI models learn from training data, as you know. They generate novel text, images, videos, and etc. This democratizes creation and blurring the boundaries between original and derivative works at precedented scales. Uh, these properties foreground the need of robust and provenance attribution and enforcement usage controls. Like when you generate an image from some AI model, actually, who is the owner? The owner is one who generated the image, or who has the rights to share their training data. So we dive into that. Because AI lacks legal personhood, ownership claims may fall to developers, like who have developed the AI model, or the prompt authors, or the joint authors who are in collaboration between the developers and the prompt engineers. So corporate entities or no settled rules that have come till today. So this uncertainty increases litigation risks and undermines the predictability. So the fair use doctrine permits the limited unlicensed use of purpose like criticism or research, but its application on training on copyrighted corpora remains unsettled and uncontested. Firms argue training is transformative while critics warn of economic substitution and scale effects when styles are content and replicated programmatically, like we have seen with the Ghibli trend that was going on Instagram. That anyone can copy the art of Ghibli style that was present in Japanese manga. So technical measures, proposed solution that we have encountered, like we can strip the metadata and add more metadata to the image, which on that will be the AI model will be trained, so that we can trace back who is the actual owner of the images. And we can embed rights and attribution opt-out mechanisms or data curation and encryption hashing for provenance tracking. These measures face practical limits as metadata can be stripped and outputs depend on developer compliance without credible enforcement. Effective protection will require standardized and auditability and ecosystem-wide adoption for real conclusions. Diffusion models like Stable Diffusion generate images via iterative denoising and noising can coherent samples, enabling high fidelity outputs and stylistic controls. Such high fidelity increases the risk of output resembling protected styles or content heightening, infringement, and attribution concerns when provenance is weak. So GNNs further illustrate the realistic synthesis via generator, discriminator, and training reinforcing the need of reliable provenance and attribute pipelines. Uh, we propose legal reforms, including defining the authorship and standard, considering the shared ownership models. Like, for example, 60% can be allocated to users, 20 to developers, and 20 to original data contributors. Technical proposals emphasize encrypted provenance tracking and standardized attribution frameworks to verify sources and credit contributors across modalities. Ethical measures call for international standards and govern training practices, attribution norms, and permissible uses of ensure transparency and equity. In the end, absent coordinated legal, technical, and ethical safeguards, the rights of human creators risk erosion as Gen AI scales to mainstream creative workflows. So, future work prioritizes codifying the authorship guidance and AI-specific fair use provisions in the law, encrypted provenance tracking, and enforceable metadata opt-out standards. The objective is to balance the ecosystem where AI augmented human creativity with transparent ownership, durable attribution, and accountable governance. Thank you. Sir, my presentation is over. Thank you.
Okay, any question from expert and audience?
No question from my side.
Okay. Next candidate is Satya Narayan Yadav, paper ID 584. Satya Narayan, conclude your topic within 6-minute time frame. Your slide is visible. You can start now. Satya Narayan Yadav.
Hello.
Yes, Satya Narayan.
Yes,
Yes, you can start, and you have 6-minute time frame.
I'm audible, sir.
My voice.
Yes, you are audible. Please continue.
Yes. Sir, my name is Satyanarayan Yadav. I'm from Lucknow, AKTU, IIT Engineering College. So my topic is use of IoT approaches in precision agriculture. So this is the content, and this is the introduction. Agriculture faces dual pressure of rising food demand and constrained natural resources. Precision agriculture leverage driven methods and optimize the conveyance of Internet of Things, sense network layer, low power communication, cloud edge computing edge, and advanced AI model terms artificial intelligence of things, enabling technology leap in PA for supporting continuous monitoring, localization, intelligence, and automated intervention. Recent. So uh, this is the objective to develop and evaluate machine learning and deep learning model to accurate classification and compare traditional decision random forest and CNN plus LSTM hybrid model approaches like CNN plus LSTM and research and methodology. This is the adopted experimental design integration IoT, artificial intelligence and of things, Internet of Things based precision agriculture by traditional malware, machine learning, deep learning, and hybrid model. Focus on comparative evaluation model using performance metrics, accuracy, precision, recall, and AFC curve. So, and use here federal learning, blockchain, comprehensive, smart agriculture applications. So, and data collections, IoT sensor, moisture, temperature, humidity, drop, health, weather, droplet for real-time agriculture data acquisition, data collection collected from the multiple source ensuring uh, and scalability data set processed, remove noise, normalize value and paper for model training. And this is digital twins integrations and federal learning blockchaining use here and deployment framework, digital twins, a smart irrigation system, edge and device for water scheduling and offers monitoring. And this is the result, the smart irrigation synthesize artificial Internet of Things contribution and disease and pest detection greater than 92% and yield precision 50 to 20% and age AI 40 to 60%, blockchain reliability 30% approx. And this is comparative result table performance comparison of machine learning model agriculture data models. So this is the accuracy result 93% and highest accuracy on hybrid 98%, 98.40 and AU 0. AUC curve 0.97. And this is the model performance, accuracy, precision, recall, comparison, decision tree, random forest, SPM, and CNN plus LSTM, and come to the IoT changing precision agriculture through continue sensing, intelligent and on-site interference, automated intervention. Significant advancement have been made to sensing algorithm and system irrigation, but barriers to adoption still exist. Feature works should focus on diverse from of robotness, edge, AI, privacy, preserving model, sharing and digital twin orchestration is a conjunction with a technical framework to enable equitable and suitable deployment. So this is the use references and read this. Thank you so much.
Okay. Can you tell me that what is the data set that you had used?
From Kaggle, data set use like Darwin and Amber use here and run in Python programming.
So do you have performed some feature selection and feature engineering on it?
Yes, ma'am.
So what are the techniques you use for that purpose?
For better result and AI, AI, IoT.
Okay. So was your data set balanced or unbalanced? And if it was unbalanced, have what techniques?
I data set use two data set use.
Mm.
So which is give best result balance data set. So that's I select and
Okay. Okay, thank you.
thank you.
Next candidate is Salu Yadav. Are Salu Yadav?
Yes, yes, sir, I'm present.
Okay. Share your PPT
Yes, sir.
and start your presentation. You have 5 minutes to conclude your topic.
Okay, sir.
Okay.
Good evening, everyone present over there. My name is Shalu Yadav. I'm a PhD scholar in Deenpothu Chotoram University, Murthal. Today, I'm going to present my one of my paper that is a
Salu,
performance.
your PPT is not visible.
It's not visible. Okay, wait, sir. Is it now visible, sir?
No, no. Still, it is not visible.
Wait a minute, sir.
No, Salu, it is still not visible. I think you should check your technical error. I am calling to the next candidate, Sivlok Singh. Sivlok Singh.
Hello, sir.
Yes,
Good evening, sir.
start your presentation. After then, we are given turn to Salu Yadav. There is some technical error in his slide, in our slide. So you can start your presentation right now. Sivlok Singh, start your slide. Salu, end your session.
Yes, sir.
Okay. Check your technical error. Okay, Sivlok Singh.
Sir,
Uh,
is my screen is visible?
yes, it is visible, and you can conclude your topic. You should conclude your topic within 5 minute time frame.
Okay, sir.
Start now.
Okay, sir. Good evening, sir. I am M. Ravi Kumar Reddy, WBL intern at NILAT Delhi. Have co-author of this research paper done under the guidance of Shivlok Singh, sir. Zero DC versus enlightened gun for low light image enhancement and object detection. Our main purpose of the project is to design a assistive vision system that enhances the frames and detects the object to deliver accurate and affordable and accessible feedback for blind and visually impaired individuals. Here our problem is that there are more than 2.2 billion BVI users who are blind and visually individuals. They are unable to safely navigate in the unfamiliar environments and they are unable to detect the objects, and they are unable to do their routine activities without second person. And there are many gaps in the current tools, which are many existing assistive technologies degrade in low light scenarios, and they have lack of end-to-end real-time operations. Our technical approach is that our system integrates the low light image enhancement with modern detectors. We used zero DC and enlightened GAN for image enhancement, and faster RCNN and YOLO V8 for detecting the objects. This improves visibility and recognition. Our strategy is to process low light inputs and apply an enhancement model, DC and over enlightened GAN, to feed the enhanced images and detected to compare detection, outcomes, and latency, and evaluate with quantitative visuals and quantitative matrices, PSNR, SSIM, and MAE, which is definition as peak signal noise ratio and structural similarity index and mean absolute error. Our paper introduces a comparative study of zero DC and enlightened GAN enhancement front ends and paired with YOLO V8 and faster RCNN. This establishes a foundation for practical and real-time assistive pipeline, balances a visual quality and detection reliability, and computational efficiency for the BI applications. Here, in the proposed methods, we used zero DCE, which is known as zero reference deep curve estimation. We use a lightweight CNN, convolutional neural networks, and which has low reference losses. In the real time, the inference time is 0.0025 seconds per image. We utilized the GPU. And for the enlightened GAN model, we used unpaired GANs, which no need of low light images and dark light images, which directly trains the model. And in it, we used unit generator and patch GAN discriminator. It has multi-component losses. In the real time, the inference loss is 0.0078 seconds per image using GPU. For the detectors, we used YOLO V8, which is speed and which is useful for real time, and faster RCNN, which is accuracy, and for complex detection, we use faster RCNN. Here we go for the zero DCE details. For the training, we used Adams optimizer, which has learning rate 1e minus 4, and beta 1 and beta 2 gradients are 0.9, 0.99. We trained for 200 epochs, and the batch size is 16. And this is lightweight and zero reference and end-to-end practical for real-time edge deployment, which uses convolutional networks and 32-bit, 32 layers in each convolutional networks, and ReLU and TANH functions for enhancement. For the enlightened GAN, we used unit with skip connection for the generator and patch GAN for discriminator. Losses are adversarial and reconstruction losses. And training samples, we used Adams optimizer, which has learning rate 0.002, and beta 1 and beta 2 are 0.5, 0.99. We trained for 200 epochs. And for the environment setup, we used Python 3.113 and CUDA 12.6, and GPU NVIDIA RTX A400, which is capable of 16 GB, and Torch 2.7.0, and processor i5 or above we can take. And these are the experimental results. This is the original one in the zero DC. This is the enhanced, and this is the detection. Here we go for the enlightened GAN results. Here original image, enhanced, and these are the two detectors. Training matrix trends in the zero DCE. The value is increased, PSNR value is increased from 18 to 24, which is a better value for image enhancement. And SSMI also increased from 0.65 to 0.83. And mean absolute error is decreased from 0.15 to 0.005.
Sivlok Singh, conclude your topic.
Yes, sir. This is a confusion matrix we have got. For the YOLO detection, we got F1 score as 0.80, and for faster RCNN 0.67. YOLO V8 is more reliable and no false alarms and balanced for real-time assistive. Here conclusion. A lightweight enhancement first pipeline is most dependable for real-time low-light assistive vision, and 0 DC is generally preferred over Enlighten GAN for speed and stability. Enhancement boosts downstream detection. Recommended stock is 0 DC front end and YOLO UV8 for real time, and faster RCN when the broader categories are taken. Our code and pre-trained model are available in the GitHub links. Thank you. For any queries?
Any question from expert?
No question.
Okay.
Okay, sir. Thank you.
Next candidate, Saurabh Pachauri. Salu, after Saurabh Pachauri, you can present your slide. Saurabh Pachauri, share your slide.
Sir, I'm just sharing my screen.
Yes, you are audible, and share your screen now. Saurabh, you have, there are many candidates waiting, so you have 3 to 4 minutes to conclude your topic.
Okay, sir. Okay, sir. Understood. Sir, my screen is visible or not?
No,
Myself,
still not visible.
comparative study of machine learning based modeling approach and introduction and a motivation. Social media platform. Is my screen is not visible? Is visible to all, sir? My topic is a introduction is a social media platform generate a massive user-centric data, concentric valuable behavior insight for the platform sustainability and the business outcomes. Decision making for the retention and growth. My objective is analyze the review survey the December in his profiling, social network analysis, embed detection, family research areas, and methodology data is via ideal time threshold of 25 seconds. The medium ideal time of distribution and the average session, the distribution of the user of the time spent in the each section and the growth microscopic features user folder is combined the section feature This is the graph for domain. There is a multi-channel analytics framework, overall graph, action graph, and a macro features visualization, large scale analysis, classification, creation, and latent location LDA. Just like chat, snap, story view, discovery view, and a content creation. This is the graph. It shows the first thing will happen most of the after a session, and the next slide is shows the session gain profiles. Just first graph is, and third graph is shows the snap, and fourth graph is blue line is used show the chatters. Key findings are the temporal action graph, modeling significant outer perform baseline, sequence model and engagement predictions, cycles complex and fast, and then infection with single high engagement. And third point is enable two methods, especially random, forecast a high yield accuracy. Limitation is the noisy interaction data, requirement of rigorous data cleaning, model interpretability, and the user privacy concern. Conclusion of the survey is the action graph modeling enhance the application of the forecasting social media are engaging framework provide an actionable insight and the production teams and the data scientists, future research intelligence, network analysis, improve the interpretably deeper privacy safeguards. Thank you. Thank you for the listening of my presentation. I stopping by sharing a screen. Thank you, sir.
Okay, next candidate is Salu. Salu, are you ready with your presentation?
Good evening, everyone.
Okay, sir.
My name
Yes,
Sir, I'm audible?
Yes, audible and it's visible.
Yeah.
Conclude your topic within 5 minutes.
Sure, sir. Sure. Good evening, everyone. My name is Shalu. I'm a PhD scholar in Deepbandhu Chotram University. I have today my topic is performance analysis of deep learning methods for intelligent transport system. So basically, my this PPT concluding this topic introduction existing approaches, and this is the introduction all about whether ITS plays a significant role in safe communication because. And why I do this analysis, because analysis gives an idea of what works best and what does not. So when I concluding or when I do my research, I come across many kind of research work, and I try to summarize all those research work in this paper so that it may help some of researchers to make suggestions and for appropriate models if they are doing some specific work for surveillance scenarios. So while we are discussing about the traffic, we come across various things, whether it is a conventional method or non-conventional method. So I will just come to a crux of all these two methods. When we discuss about the conventional method only discuss about the Euclidean values. Non-Euclidean graphs values it does not include. Euclidean or grid-based, it just discuss about, for example, it discuss about the flat spaces, like it does not line of sight things it can conclude, but when but in real environment there are curved surfaces. There are in urban environment, for like we are collecting a data from a GPS based navigation, we are modeling something. So in that case, conventional method does not fit good, so we come across this GCN method as a non-conventional method. So here is the comparison of both this conventional non-conventional method, and these are the various challenges when we come across the non-conventional methods, and this flowchart shows the some spatial method, temporal problem or other challenges. Spatial non-Euclidean spatial relations, that means we are discussing about some properties that refers to the arrangement or some relationship of different traffic vehicles, whether they are in roads or some intersection or there are some traffic light. And non-linear temporal, it's totally about the dynamics features, that means we are talking or we are asking about the sequences, for how long they are from the in time frames, what is the duration, what is the timing of the event, what is the phenomena over time, because there are in a weekdays there are some week hours, there are some weekends on which we get some extra traffic on, there are some days when we don't get some extra traffic, so we have to manage all those traffic condition according basis on the present scenario. And moreover, other includes the heterogeneity, error prone data. While collecting data from some sensor, we may get some heterogeneous data or some error or some data which is not full-fledged to train our model. So these are the other challenges while we are analyzing the traffic. Here I compare the basically both, that is conventional and non-conventional method. Sorry, ma'am. Okay, this is about the conventional, non-conventional. Their strength and limitation are summarized in some way, like how the GC and GAT, which are non-conventional method, they capture the spatial and temporal dependencies of the graphs, and CNN and RN, they only captures some spatial, some temporal sequences. So while facing both these problems, that is spatial characteristics fetching and temporal characteristic fetching, I come across some papers that make use of some hybrid model, and those hybrid model are CNN, RNN, LSTM, GRN, GC, and RNN. And I performed some kind of a research work on GT SRB, and I came across, while some traditional method come across with the 19 traffic, then accuracy is somewhat up and down. And this is not my work, but I collect or I summarize all this work, how the you only look once model detect all kind of objects, and why it is so fast, and why it get it provide this much frames. FPS is the 30 to 50 frame it provides per seconds, but it's overall small object. For suppose if you are if there are multiple heterogeneous kind of a data, so somehow its accuracy somehow compromised somewhere.
Shalu, conclude your topic.
Yeah, okay, sir. So this is all about the real-time traffic prediction application. While concluding all those things, I come across some real things that if we are able to capture all those features, we can dynamically traffic control. Dynamic traffic control means if on a four-way, if there is not a number of vehicles on one way, we can dynamically change the signal lights, and we can get the traffic timely to be segregate. And this is all about the conclusion future work, which I have told you earlier. This is the intelligent transport system help for supporting secure and efficient. We can make this secure with the help of federated learning. I have already used the federated learning with some GAN, and my paper is under a revision. So this is all about. Thank you so much. These are some references. Most of the references are the latest 24-25. Thank you so much.
If any question can ask.
Yes, sir.
If anybody has question, can ask. Parul ma'am, if you have some query, you can ask.
Hello.
Yes, ma'am.
You had used some hybrid models. You had compared the performance of the hybrid models, or you had used your own hybrid model?
Ma'am, I have used one of my hybrid model, which is named as CanFL, and I compared
Okay.
it, but I did not include in this paper because some hybrid model I compare the performance, but
Okay.
the proposed model paper is under review. Once it get published, so for sure I will compare that my particular
Okay.
proposed model.
Okay.
Yes,
Okay.
ma'am.
So right now you had not mentioned that model in this paper.
But the rest of models, 2 or 3 models, I have performed the processing on some KT dataset and LISA datasets by
Okay.
myself. Yes, ma'am.
Okay, thank you.
Okay,
Thank you so much.
Thank you, Shalu.
Okay.
Next, show with money. Are you there? Paper ID 788. Show with money. Okay. Next is paper ID 165. Vanishri. Vanishri D. Are you there?
Sir,
Okay.
Ime Brahman.
Paper ID 882 AK Singh from RBS College. Are you there?
LNG College.
Mr. AK Singh, are you there? Okay. Paper ID 164. Avnash Kumar, MMNIT Allahabad. Are you there? Okay. Paper ID 599. Rhythm Singh. Rhythm Singh, Carolina, USA, online. Are you there?
Sir, paper ID 298 K Ime Brahman.
298. नहीं ये कह रहे नहीं
पिछला सेशन
सर आपका सेशन हो गया है योर सेशन इज ओवर सर यू आर इन 2B
Sir, paper ID 298 K Ime Brahman.
तो मैडम 2B वालों को लेना आए ठीक है सर यू कैन प्रेजेंट 5 मिनट्स हेलो अरे पुराना वाला दिखाना था लिस्ट कौन सा है हाँ पेपर आईडी 298 am I
298 Ime Brahman.
okay you have 2 to 3 minutes sir you only present your key finding
Okay.
share your screen.
paper ID 298 please share your screen we are running short of time hello
Oh, can I present the paper ID 498? Sir, I am waiting. Sir, I am waiting since 4:30.
sir Raman Purai okay
Yes, sir. Session 3A, sir, 4:40 timing.
okay you can start you have 5 minutes no,
Okay,
only
sir.
focus on key findings
I think, sir, K. Ivaraman have come.
paper ID 298 please wait we will take you after this third session after 6 you should wait sir
Okay, sir. So I will. So
you
I
can
will
start
present,
sir
sir.
Raman Purai sir you
498
can
Raman.
start
Okay, sir.
Yes, you can start.
Okay. Is my screen visible, sir?
Yes, visible.
Good morning, everyone. My name is Raman Kurai. I am from Manurachna, Faridabad. So today, my topic is cloud data security in healthcare. So this is my index. First, I will introduce with abstract introduction, literature review, methodology, result, and conclusion. So my abstract is healthcare. Healthcare organizations are more and more utilizing cloud services for storing and processing data, exposing patient confidential information. So to create security threat. So in this research paper, prevalent threats to cloud data security in healthcare are explored, and prevailing mitigation factors are compared to a quantitative content analysis of 73 reviewed articles and 16 industry industry reports from 2019 to 24. The analysis indicate that the healthcare cloud infrastructure are more at risk from ransomware attacks, up to 168%, since those are 2020 insider threats and third-party vulnerabilities. Effective defenses consist of employing zero trust architecture, and which reduce breaches by 43% among the survived organization. HIPAA compliant encryption protocols and AI-powered threat detection solution can identify 91% of new attack patterns. Security audits and employee education demonstrate significant levels of improvement in vulnerability management. Students indicate that to safeguard healthcare data stored in cloud, and a multiple level security policies must have technical means and policy enforcement and human factor, and this is in order to ensure the policy is able to adapt evolving regulatory environment. And this is the introduction. The introductions are as same as the abstract, but there are some changes. So I'll move for literature review. Sir, in literature, these are some literature review that that other authors are do in the past. Some papers are from 2022 and 2023-24 in cloud data security, and I review them and find some methodology and limitations from that. And sir, these are my methodology. There are three phase strategy in combining literature review, quantitative survey, and data analysis and qualitative validation to study cloud data security threats and mitigation in healthcare. Phase one, systematic literature review. So there I followed Prisma guidelines searched by 5 databases: PubMed, IEEE, Explore, ASMDL, Scopus, and Web of Science. And initial field 487 research by final conclusion. So this is my phase two, quantitative data collection analysis, and these are my source survey 4-1 response, and this analysis. These are my analysis techniques, sir. Correlation analysis, multiple regression, and square test in an ANOVA. And so this is phase three, quality validation, semi-structured interviews, 4 CICO, security and director, focus group 4, group 6, and each. Implementation challenges and effectiveness, and strategy validation and practical insight. And so these are some results that I am talking about. The attack that are in healthcare in cloud data security in healthcare. So the first one is ransom, the most frequent, the 38.2% most frequent threat, and then phishing attack 24.7, stolen 1.6, and stolen credential 15.6%. And so these are security control, effectiveness implementation. So zero trust architecture low 31%, and effectiveness high 86%, audit login high 93%, moderate 58%, multiple factor auth high 82%, and strong breach impactness. And then large hospital have average breach cost of 5.73 million, and average recovery time is 92 days. Small facilities has 0.82 million for 3 days. And sir, this is the last rising cloud related incident, total cloud incident 412, and cloud related incident 27% increase to 64%. Cost, rapid cloud adoption outpaced security investment, need for balanced security, technical plus administrative plus monitoring. These are some images. Then this is the conclusion. This is the comprehensive analysis of the cloud data security threats and the countermeasures in the healthcare safe. Our analysis shows that the healthcare organizations are exposed to a constantly changing threat landscape with ransomware, with credential attacks, with the cloud attacks themselves expanding exponentially since 2019 through a traditional security control zero trust model perform better even with the reduced deployment. The study indicates an unprecedented disparity between effectiveness and security control implementation that warrants realignment of the security spending based on the facts that not compliance principle. Organization that had integrated security measures and involved the integration of the technical round, administrative controls, and continuous risk surveillance indicated a few breaches compared to organizations that had disintegrated security program. As healthcare cloud adoption continues, these results are critical to security leaders creating defense strategies that face strong security against healthcare, special operational requirement against the ongoing regulatory compliance and increasingly sophisticated cloud. These are some references which are from 2021, 22, 23, 24, and 25. Some are 25 also.
Next candidate is Pankaj Kumar, paper ID 587. Pankaj, are you there?
Sir, Raman Kurai, sir, I have completed, sir.
Okay, second.
498, sir, I have completed Raman Kurai.
Okay. Start your name, Raman Kurai.
My paper ID is for 587 and I have not given the chance to present.
Okay.
Yes, sir.
Pankaj Agarwal,
Okay, sir.
587 paper ID.
Sir, Raman Kurai, sir, should I leave, sir?
Yes.
हाँ, आपका presentation हो गया रमन.
Okay, sir. Thank you, sir.
Can leave. Okay. Pankaj Agarwal, 587.
Yes, sir.
Are you going to present your presentation?
Yes.
So, Mr. Rohitendra, you should wait.
Yes,
Pankaj Agarwal will present his presentation first. Mr. Pankaj, you have only 2 to 3 minutes and focus on only the key findings of your research.
Okay, sir.
Share your screen. After Pankaj, you can present your presentation, Rohit.
Yes, sir.
Pankaj, share your screen. Rohitendra, disengage the screen sharing.
Yes, sir.
There is a issue in network. That's why I was disconnected.
Okay. After Rohitendra, you can start. Okay. Rohitendra.
Okay.
Yes, sir.
Proceed. You have 3 minutes, 3 to 4 minutes to conclude your research. Rohitendra.
Yes, sir. Sir.
Share your screen again and present your work.
So,
Okay.
Good afternoon, sir.
Good afternoon.
My title is Enhancing Network Efficiency through an Energy Saving Geographic Routing Protocol. Network abstract problem. Wireless sensor networks suffer from higher energy consumption and low lifetime. Solution: improve geographic forwarding energy efficient routing protocol with node location and reinforcement learning. Outcomes: more energy efficient, scalable, and robust than existing protocol. Keywords is geographic routing protocol and geographic forwarding energy efficient routing protocol, geographic energy efficiency, and node localization. Reinforcement learning. The introduction is a wireless sensor network is a network are important component of.
Please focus on your key findings.
Yes, sir. Wireless sensor network and energy efficiency. Wireless sensor network play a key role in real-time monitoring across various fields. Energy expenditure and network lifetime are important constant and wireless sensor network. Geographic routing protocol provide a means to reduce energy expenditure using node location information. Current prototype geographic routing energy efficient routing protocol use location and recentered energy, but they are plugged by load ambulance and reverse discovery hastage. Progress advanced geographic forwarding energy protocol with reinforced learning for adaptive routing. There is a literature view, there is authors and methodologies and limitations. Their objective is to enhance performance of geographic forwarding energy routing protocol using node locations to save energy and extend network lifespan. And second is to improve efficiency and balance traffic by applying reinforcement learning algorithms. Third is one evaluate and compare performance with existing protocol on various parameters. The first solution is geographic forwarding energy efficient routing protocol with reinforcement learning. First is proposed a better geographic and energy efficiency routing protocol. Second one is implement reinforcement learning algorithm for adaptive routing. Employ precise node locations information in routing decisions. And reinforcement learning facilitates intelligent routing, utilizing, avoiding redundant transition and saving energy. There is a figure is one. There is a routing protocol of GRP. There is a source. There is a the route head and there is a base station. The complete process GRP system start network initialization and final node locations energy check, then K mesh clustering, and after that check congestion. If it is no, so re-evaluate routing process to continue process. If it is yes, so check traffic, and after that forward details and allow energy nodes, then increase lifetime. And these are main components of geographic forwarding energy efficient routing protocol and reinforcement learning. Node classification, it is node classification node into classes according to energy levels and regional head selections. Dynamic choose region head with grid and semi-circular clustering. The third is energy routing, geographic forwarding, and select low energy cost nightboard when move towards an destinations. Transmission power controls adapt transmission power according to the next hop distances, and deep learning for traffic balances utilize energy nodes essentially and congestion level adaptability to control routing paths. There is methodologies. Reinforcement learning is Q-learning for adaptive routing, make use the returns energy node centralization and congestion, and surveillance traffic dead nodes and hybrid routing and clustering methods. Node classification based on energy levels, regional head election based on grid and semi-circular clustering. There is state node energy consumption levels, sync distance, number of nightboards, access forwarded and nightboard drop packet or reduce transmission rates, rewards save energy, effective delivery, and set awareness. And to get result, the simulation environment and identify the simultaneous platform applied network topologies, fixed and mobile sensor nodes distributed over given the area. Traffic models bit and event traffic performance parameters, energy efficiency network lifetime packets delivery ratio and delay and throughput. There is a result expected that energy saving compared to current location protocol double network lifetime by avoiding low energy node trading and node balances. Besides congestion in the Q-learning rewards survey. There is a graphic energy efficiency comparison network lifetime in first node diode and half node diode and last node diode. PDR in delay throughput and graphics. There is a comparison performance. There is a geographic forwarding efficient routing protocol. Reinforcement learning is energy efficiency 0.95. Network lifetime is at 2600. PDR is 95%, and delay is at 50.2, and throughput is at 25.6. There is a performance comparison. Geographic forwarding energy efficient routing protocol plus reinforcement learning versus geographic forwarding energy efficient protocol in AODV and LEACS. DF geographic forwarding energy routing protocol is reinforcement learning. There is no lowest energy use There is no longest network lifetime, no highlight PDI 98%, no lowest delay 45% millisecond, no highest throughput 410 Mbps. In their conclusion, give private deviation which reinforce learning optimize the utilization of node space of conserve energy and maximizing network lifetime. Adaptive routing and hybrid congesting existent energy efficiency and scalability. Then reinforce learning optimize traffic balance, congestion avoided, and routing optimization. Then improve development routing and energy efficient routing protocol performance. Save energy, optimize lifetime, adaptive balances traffic better than area out constant combined equation of machine learning and to implement from various social networking. These references are given. Thank you, sir.
Pratiksha God.
Yes, sir.
You can present your presentation.
Yes, sir.
You have 4 to 5 minutes and focus on your key findings.
Okay, sir. Good evening, all of you. Myself, Pratiksha Gaur. I'm an MTech scholar from Computer Science Engineering, Dr. K.N. Modi University, Rajasthan, under the supervision of Mr. Amit Verma. My topic is lightweight CNN LSB, stenography for secure meta data embedding in UAV communication. The introduction. Introduction is here. Unmanned aerial vehicle play a vital role in surveillance, disaster response, agriculture, and environmental monitoring. They operate in resource constraint in communication is essential. But there is some challenges. The challenges is transmitting metadata via separate channel, increasing bandwidth uses, transmission delay, and interception risk. For their challenges, we find out some solution. A unified framework combination lightweight CNNs for an onboard image classification with the least significant bit steganography to embed metadata directly into the UAV images.
First, share your screen, then only you can present.
And for this, we contribute some techniques. Integrated.
Your PPT is not visible right now.
Sorry?
Yeah. Pratishtha, your PPT is not visible.
Just let me check. So right now?
No. Not visible. Not visible. Share your screen.
Now?
Okay. Now it's visible.
Okay. Shall I start from starting or?
Yes. You can start from starting.
Okay. My topic is lightweight CNN and LSP stenography for secure metadata embedding in UAV communication. Introduction. Unmanned aerial vehicle play a vital role in surveillance, disaster response, precision agriculture, and environment monitoring. They operate in resource-constrained and dynamic environment where secure and efficient communication is essential. But there is some challenges. Transmitting metadata via separate channels, increasing bandwidth uses, transmission delay, and interception tasks. So for this, we find some solutions. A unified framework combination lightweight CNN for onboard images class directly into the UAV images. For this, we contribute some techniques. Integrated pipeline for classification and metadata embedding. Validation on CIFAI advised drone data with PSNR 63 dB and SIM 1.0. It provides secure and lightweight and bandwidth efficient solution for UAV communication. existing method. Metadata transmission through separate channel, increasing bandwidth, delay, and anticipation risk. LSB steganography is simple and lightweight, but unvariable compression and detection. Transform domain method offer robustness, but incur high Hello.
Yes. Continue.
Hello.
Continue. I share your screen.
Is in 2025, which is lightweight crypto plus steganography and the limit. The next is the proposed framework for this onboard UAV.
And conclude your.
Hello. Hello.
Share your screen.
It's not visible.
Pratiksha, share your screen and conclude your topic. Am I audible?
Sir, is it visible? Hello.
Yes, Pratiksha.
Is it visible, ma'am?
No, it is not visible. I can't see at my end.
Hello.
Yes, it's visible. Now you may conclude.
Hello.
Pratiksha, continue. Now it's
Yes,
visible.
sir. Okay. Solution for this, and there is some algorithm we represent to find the solution. How do we this part? And there is some methodology of data set and processing. Here I show that we contain suppose 60,000 color images across the 10 classes. There is in this methodology, there we find the 10 classes and we divided in some parts, which are some training part and some testing part. And the images of this color images is divided into 32 and 32 pixel. And we normalized it in 0 and 1 bit range. So I describe in this slide the whole thing. And this slide show the flowchart of the all methods. It show that we convert the original data into the binary sequence in the form of 0 and 1. And with the approach of LSB, which is convert the of least digit with if I have 0 digit, then it convert to 1, and after that we flow the all the process, and after that we find the all original images in this. There is some mathematical model. We conclude this the all thing with mathematical presentation. There is some formulas we used for this. And the experimental result is shown in this slide, which is the CIFR10. This is the data set which show the technique of accuracy. And Wisdom, this is also show the technique of accuracy of result. And this is the graphical diagram of this experimental result, which we were done in the mathematical form. Is the performance, evolution, and reliability. The theoretical analysis show 95% recovery success rate when error probability is low. The framework is ensure successful metadata extraction under normal condition. Probability of correct recovery is very high for short message, which is less than 128 bit. Reliability can be further enhanced using adaptive embedding in high texture regions, error correction code, interrelieving technique, performance evolution, computational efficiency. Bottleneck like CNN interface but feasible with compatible architecture, LSB embedding and extension complexity. Overhead is negligible compared to CNN interface. Lightweight CNN model allow on-board UAV deployment in real time. Overall system is suitable for resource constrained UAV platform. There is performance comparative analysis chart, which is show which one is good and which one is moderate. There is some conclusion of my work, that is the eliminate the need for separate metadata channel, improving bandwidth efficiency, confidentiality. Classification accuracy 33%. Image quality PSNR 63-bit SSIM was 1.0. And for future work, this is the improve the classification, employ deeper lightweight models, enhance robustness, scalability, and all. And there is some references which I used for this. Thank you. Hello.
Thank you. Next.
Thank you,
Next
sir.
candidate is Pratiksha T. Paper ID 597. Are you there?
Pankaj, this side, sir. Shall I start? Because that time.
Pankaj Agarwal, you can start.
Okay, sir. So my topic is, my name is Pankaj Kumar and I'm a research scholar as well as working as an assistant professor in Mangalaitan University, Aligarh. So my topic is AI-enabled self-immunizing medical IoT devices, a cybersecurity framework for autonomous threat mitigation. So I am a research scholar and my guide is Dr. Pankaj Rai and my co-guide is Dr. Bimal Kumar Mishra. So this is the index and this topic will be covered in this upcoming session. So this is the abstract. The medical IoT devices have transformed healthcare by enabling constant patient monitoring and quick diagnosis. However, their extensive and vast connectivity also brings new challenges related to cybersecurity risks that traditional defense struggle to manage, especially due to the devices' limited computing resources. To address this challenge, we have presented a smart AI-driven security system that empowers MIoT devices to independently detect unusual behavior. It also can react to cyber attacks and restore themselves without intervening human. Our solution combined the advanced deep learning technique for spotting anomalies in real time with reinforcement learning agent that choose the best actions, such as isolating affected parts of reverting to secure software versions. For the implementation of this, we tested the system using two real-world databases like boat IoT, and the MED boat IoT. These data achieving over 96% accuracy in detection and successfully countering more than 92% of the threats while the cutting downtime by 41%. These findings highlights how the intelligent and adaptable framework could greatly improve the safety and the dependability of the healthcare network, paving the way for more secure and autonomous MIoT devices in critical medical settings. So this is the introduction. These are the literature review, and I have covered some recent paper, also some old papers from 2015 to 2023-24. And these are the findings of these research papers. So what is the methodology? This research proposes a comprehensive AI-enabled self-immunizing security framework tailored for medical IoT devices. The methodology integrates deep learning-based anomaly detection with reinforcement learning-driven adaptive responses to autonomously detect, isolate, and recover from the cyber threat. The design prioritizes minimal latency, lightweight computation, and real-time response, essential for the resource-constrained medical devices operating in critical environment. So the system consists, first one is system architecture, second level is the data collection and pre-processing, third one is the anomaly detection and deep learning, fourth one is adaptive response using reinforcement learning, and next is immunization and recovery logic. Next one is training setup, and next one is the evaluation metrics and model assessment. So this is the architecture of my workflow, where the data is collected and pre-processed and train the model, and it will show the output, the workflow and learning of the machine learning. So data collection, as I already mentioned that I have taken two real-world data, boat IoT and boat IoT, which is available in PubMed. And this study employs two publicly available cybersecurity datasets, boat IoT and MED boat IoT, to develop and evaluate the proposed enable self-immunizing framework for the medical IoT devices. These datasets simulate realistic MIoT devices behavior under begin and the malicious conditions making them ideal for training both deep learning and reinforcement learning models. The bot IoT dataset includes over 70 million records of network traffic from simulated IoT devices covering attacks such as DDoS and DOS and reconnaissance. While not specific, its diversity and the volume support effectively anomaly pattern modeling. The MedBot IoT dataset offers medically relevant traffic data from the devices like ECG monitors and the infusion pumps, simulating botnet-driven attacks, including scanning and command and control. The BOIP data in the studies sourced from the work by which provides diverse network traffic scenarios, including multiple attack types. Similarly, the MED bot IoT data set introduced by is designed by specifically for the IoT system and indicates realistic threat simulations. So these are the data and the attack types. So in bot IoT, the total sample is approx 4 lakhs. And key features use packet count, flow duration, and entropy protocol and rate. Attack type is DOS data theft and fuzzing, beginning 0 and malicious 1. And pre-processing mean max scaling and SMOT code balancing. And in MedBot IoT, approximately 2,10,000 data has been sampled, and sensor updates, frequency, header, entropy, TCS flags, and size. Port scan, MITM. Yes, sir.
Please conclude.
Okay, sir. So in result and discussion section, we have compared two sections, autoencoder and LSTM. And LSTM achieved 96% of accuracy, approximately, and autoencoder is successful in 94% approximately. So this is the learning curve, and The success rate is increased by DQ improves the threat mitigation performance over time, starting with the success rate of 45%. Initially, it is 45%. The model converts to a stable success rate of the 92.4% after approximately 100,000 training episodes, configuring the agent's learning capability and policy optimization. This is the system level performance, and it is higher in downtime reduction. This is the comparative analysis. For methods used signature based, it is approx 83%. In the static DNN based IADS, it is 90%. And proposed LSTM and encoder, autoencoder plus DQ framework, it is approximately 96.8%. And precision is 95%. F1 score is 96%. False rate positive is reduced to 2.3%. And mean time to mitigation, which is approximately 1.2 seconds, and CPU usage is 6.5%. So this model will work efficiently. Conclusion: this SSG presented a novel AI-enabled self-immunizing cybersecurity framework for medical Internet of Things devices, integrating LSTM-based temporal analysis, encoder-driven anomaly detection, and reinforcement learning-based adaptive mitigation. These are the references. Thank you so much. This is it from my side.
Okay. Next is Harveer Singh. Paper ID 595.
Sir, MEM 298 paper.
After this presentation, you can present your work.
Sir, 4:40 timing.
After 10 minutes. Mr. Harveer, are you there?
Sir, MEM 298 paper code.
298. You should wait for 10 minutes. Next 10 minutes.
MEM 1.
After this presentation, you can start your presentation. Mr. Harveer, are you there?
Yes, I'm present.
Okay, start your presentation.
Okay, I'm sharing.
Harveer ji, we are running short of time, please. Hurry.
Slide.
Harveer ji, is there any problem?
Sir, I'm just sharing.
Paper ID 298. Amaya Varnam.
Maya Varamban.
Okay. You
298.
can start the presentation. You have only 5 minutes, sir.
Okay.
Please share your screen. Sir, any problem? Next. Harveer Singh, are you ready?
Ready?
Okay. Next candidate is Pratiksha T. Are you there? Professor Samruddhi. Sanjay Rao. Paper ID 191. Are you there? Paper ID 149. Ankita Maheshwari. Are you there? Anybody who wants to?
Sir, this is Ramya, sir. Paper ID is 482. Shall I proceed?
Okay, you can proceed. Share your screen.
Yeah, just a minute, sir. Sir, is it visible, sir?
Yes, visible. You can start. Please focus on your key finding. You have only 5 minutes.
Yeah, okay, sir. Good evening, sir. Good evening, everyone. I am Ramya, research scholar from DG Vaishnav College, Chennai, Tamil Nadu. Today I am honored to present my paper, Blockchain Function Virtualization for Energy Efficient Mobile Offloading. This is my objective introduction, proposed blockchain function virtuality, then offload heavy blockchain task and improve energy efficiency, reduce latency, ensure security and trust.
Ramya, we are not able to see your presentation. Somebody else has, I think, shared the screen.
Oh.
Ramaya, is this your
Yes,
presentation?
now it's visible.
Please continue.
Is it audible, sir?
Yes, continue. Please.
Yeah.
Ramaya,
The introduction is with the rapid growth of mobile application, user demands for performance are increasing, yet mobile devices are constrained by limited battery power and processing capacity. On the other hand, blockchain offers transparency and strong security, but it requires the significant computational resources. My problem statement is
Please don't share your screen. Here, Ameya is giving his presentation. Continue, madam.
Yeah. Sir, my problem statement is blockchain tasks such as mining, verification, and encryption drain mobile energy, while heavy computational creates latency and overhead. Therefore, there is an urgent need for a framework that delivers both security and energy efficiency. The motivation is offloading saves energy but raises trust issues. Blockchain ensure trust but consume more forever. The research gap is no framework is balancing both aspects. Related workers, the related study mainly focus on individual aspect. Mobile offloading improves efficiency, blockchain enhances security, and network functional visualization provides flexibility. However, none of these approaches combine of all these three effectively. The real research gap is lies in the virtual blockchain functionality to enable efficiency and secure mobile offloading. The energy consumption remains the biggest challenge. Consensus and encryption require significant battery power, while always on connectivity further drain resources. As scalability increases, workload also rise, making process heavier on limited devices. Stronger security mechanism usually mean higher energy use, creating trade-off that needs to be resolved. The limitation of my existing solution is cloud computing is have a limitation. Cloud offloading is efficient but lack trust. Blockchain only system and secure but energy draining. NFE only approaches are efficient but lack immutability. So this make it clear that a hybrid solution is required for this. So on our proposed blockchain functional virtualization framework addresses these limitations by decoupling heavy blockchain tasks and executing them on cloud servers using NIF principle, while blockchain verification ensures security and trust. There are three architectures: that mobile layer, virtualization layer, blockchain layer. At the mobile layer, lightweight devices are generated transaction. At the virtualization layer, cloud server runs heavy blockchain function. Finally, at the blockchain layer, consensus, verification, and tamper-proof ledgers are maintained. My process is straightforward. The mobile device offload blockchain related work external server where cloud server execute resources incentive operations such as consensus and cryptography. The blockchain layer then secure and verifies the result before sending them back to the mobile devices. So this is the performance analysis by using the parameters, that is energy, latency, throughput, and security. This graph is the comparison between the energy, latency, and transaction security. The traditional approach show medium efficiency but lack of strong trust and security. The NFU only model achieves efficiency and low latency, but it does not provide the sufficient trust. Blockchain only model ensure high security, but it suffer high energy consumption and high latency. The proposed BFE model balances both. It reduces the energy and latency compared to the blockchain only, increases the throughput, and at the same time it maintains the strong security. So therefore, BFB is efficient because it optimizes energy latency and throughput while ensuring high security, unlike the other approaches which only excel in one area. So by the conclusion, the blockchain functional virtualization successfully reduces the energy consumption on the mobile devices, improve transaction throughput and performance, and maintains high-level blockchain security. It achieves balanced trade-off between the energy efficiency and trust, making it promising solution for the future secure and efficient in mobile computing. So these are all the references I have taken. Thank you for the opportunity to present, sir.
Thank you, Kiramaya. Sir, if you want to ask question, you can ask, sir. Satya Bhushan, sir, or Preeti Verma, ma'am. Okay. Kiramaya, Varlam, sir, you can.
Thank you, sir.
Okay.
Yes, sir.
You can start the presentation. Emma Mariam, sir, 298. Paper ID. Sir, please focus on your key findings, sir.
Sure.
Then start the presentation. Sir, please continue. Any technical problem, sir? Any other participant who wants to present this paper?
Oh yeah. Yes, sir. I want to present.
Okay. Share your screen.
Please give me the permission.
Emma Mariam, sir, please.
Okay, sir. I am sharing. Sir, there is no permission you have given. You cannot start screen share while other participant is sharing.
Sir, advanced predictive analysis of that I have taken.
Okay, sir. Now I am sharing. Yes, sir. Okay, I am sharing.
Mr. Habir.
Yes, sir, I'm sharing. Just a minute.
Okay.
Just a minute. Just a minute. Just a minute. Just a minute, sir.
Okay, Harbir.
Just a minute, sir. So 1 minute. I'm sharing.
Okay. On behalf of Institute of Engineering and Technology, Dr. B.R. Ambedkar University, Agra, I, Dr. Amit Singhal, would like to give my vote of thanks to Dr. Satya Bhushan sir and P.T. Verma madam, who have spared their valuable and precious time for this for sharing this session. Thank you, sir. Thank you, madam. We are very thankful and grateful to you, both of you.
Thank you. Thank you.
Okay. Thank you.
Okay, sir. Thank you, sir. Okay. Can we accept, sir?
Yes, yes.
Thank you.
Okay, thank you.